systems or other systems on Nix, you can have atomic transitional or transactional system rebuilds. So if you were to rebuild your system from the flake, you'd be able to go back to that version, and it's never like in a state where it's not booting. It's always going to work, or it's never going to build. And you can always change the system generation in the bootloader. So if you had a build that was working and you messed up something in your configuration, you can boot back to that older version. And it's completely immutable. We talked about this earlier with Nix, and that's the same kind of theme going on with NixOS. It's never going to change. If you have a package installed in the Nix store, that's read-only. So, are there any questions about Nix and NixOS as the basics?
What gives you the confidence to go to the next immutable version?
So
because you're not staying on the same thing forever.
So when you have a flake, there's a flake lock. And when you build your system, it's going to stay on the same version of Nix packages. So unless you update your flake lock to get the latest packages, you kind of know that your system is going to work because there's no errors when you're building it. So if you feel like you're ready to upgrade to like the latest version of Nix packages to get the latest package versions, then you can do that. And I think you get that confidence after you have a working system, and it's just like everything's working, and you're like, I kind of want to update my packages, get the latest security fixes, things like that. Then you just run the flake lock update command, and you have all the updated packages. It's usually going to work. Sometimes there's some errors if you're on the unstable version, but once you rebuild from that, usually if there's like an error, it's something about like a package changed names or some package set got deprecated, then you can fix that pretty easily. So it's not like you're going to have an unbootable system by updating. It's pretty stable.
So I have one quick question.
Yeah.
You say, so you're concerned with just bootability, or what about other issues with like drivers that behave oddly?
I haven't
you
had...
discover that a week later when you actually try to run a program, for example.
Yeah, I haven't had any issues with that. Most of the issues I have when I update are due to the system having a package that got deprecated or something got renamed because I'm on unstable. So I think if you're using the unstable version, you don't really... You have more to worry about like drivers getting updated or having some issues with...
I'm thinking specifically about like an AMD GPU regression, for example, that happened last year at Arch, and it took me an hour or so to figure out which it was. I pinned that version, and then my problem solved. But I don't know if Nix is actually going to be able to solve that. In the same way.
You can pin versions using Nix, but I haven't had an experience where I've had like something like yours, driver issues. I wouldn't imagine there would be. I would imagine they would give you some sort of warning because there's a lot of evaluation warnings if there's something. Oh, question. 1 second, I'll get to you soon. If you have a regression with like a driver or something, you can always just boot back to an older generation. So if something doesn't work on a newer version, you can just go back to an older version.
Okay, so there's like multiple.
Yeah.
A snapshot history.
Yeah. You have generation history in the bootloader, so you can select an older version.
To speak to that question directly, I had that exact situation happen with my 1080 Ti that I'm running NixOS on.
I have the same GPU.
Yeah. So I was running my 1080 Ti on NixOS, and most recently, the NVIDIA drivers, I'm still using proprietary ones, sue me, but they got updated, and they don't support the 1080 Ti anymore. So it did break my build. I rebooted, and my NixOS machine had one monitor at like 480p, and I was like, the heck is going on? So I rebooted into a previous generation of NixOS that still had the drivers that worked, and then I went in, found the config to pin it to a version of the drivers that would still work continuously, and then rebuilt with that, and everything was back to being hunky-dory.
Could you split though? Could you keep one thing on one version and advance the rest? Because with Arch, once I figured out which problem it was, I was able to keep updating my kernels from that point on, but I still kept the old driver pin. So it's...
Yeah, the thing that I pinned was specifically the NVIDIA driver that I was using.
Okay.
You can make a derivation for that and just pin it to that specific version for that package
so it
only.
just gives you more control over what specifically is changing.
Yep.
And do you get to modules and conditionals later on in the talk?
Well, we use module like for the configuration, but we don't actually talk about like the core Nix language foundationals. We just talk about making a configuration using Nix, which is a very high level overview. Just
one of the things you can do is if statements if you want to do different things for different machines. So
you can compare host names, things like that. Any other questions?
So you said earlier that the next package manager source or downloads on the server copies of packages from
Yep.
Various
Yeah.
different repositories, apt, RPM,
Well,
Rust.
so it doesn't take them from apt. It has its own system of getting those packages from its actual source and then using Nix as the language to package that. And it's a little confusing, but it doesn't have all of the packages that apt would. It has basically it basically has every package that you would need, but it doesn't have all of the same ones because it's not just like copying those repositories. It's sort of its own. It's more like for pip, for like Rust crates, things like that are like language dependent. Those are package sets that are copied over. They're like, there's just one Nix configuration flake that sort of bundles all of those into one thing that would work with Nix.
So the Nix store, the gentleman that wrote it, he got a PhD for it, but the store is a copy of every input for each package,
Mm-hmm.
creates a SHA SHA hash, and that's what's in the store. So that it allows you to be very, very granular in what was built and what you're actually using.
Yeah, and it's also read-only, so a user can't just like mess it up and modify those inputs. So, any other questions?
Is there a reason why there's so many packages compared to?
Yes. So there is a pretty big downside to using Nix, and that's because the Nix store is read-only, and you can't just like add any package you want off the internet. It kind of has to be packaged for Nix. So if you want to add a package, the main way that you would do it is by either making your own derivation, which is basically just writing your own Nix configuration for that package, or you can get it from Nix packages. And that's kind of why Nix packages is so big, because you can't really just download any package off the internet, like an RPM, and run it on Nix. It would need to be specially packaged for Nix.
So the reason it's so big is because you have to package it to use it.
Yes, yeah. All right, let's move on. So, what can Nix do? So, this is my home lab. It's configured entirely with Nix, and NixOS supports remote deployments. So, I can build a Nix configuration, its system, on my PC, and wirelessly send those files to my home lab. So now, because the home lab only has half a gig of RAM, it's not able to build itself. So I can send it over the internet and have a fully working system. It wouldn't auto-update, I would have to manually update it, but it's better than having something like Debian running on it, where it would constantly be updating itself. I want something that's super simple. It's only running services that it needs. It's completely customized to fit my needs. So I've gone with Nix, and it's able to, I mean, you can extend this to just more than just home labs. You can deploy to a VPS or a cloud using the same idea, and you can declaratively configure what's on that VPS or the cloud. So you don't have to add any packages or any systems that you wouldn't need. Oh yeah, and if the SD card fails, because that's quite common on Pis that are running on services that require reading and writing from the card, then you can just build from the flake again and have another working card just like as it would for this one. Oop, wrong way. You can make dev shells with Nix. So a development shell is basically a temporary environment that can declare tool chains, runtimes, compilers, environment variables, and containers. And you only need to run one command, and you'll have all of these set up as a temporary environment for you to run your builds or development. And you can, I mean, it can even work in an IDE. So if you had something like I forgot the term, but it's syntax highlighting for a program, you can run the development shell,
Like a
and
linter?
it's
Like a linter?
yeah, like a linter, like any of your IDE programs, things that would require these packages or systems to be set up, but you didn't want to have it on your system the whole time because you're not constantly developing, then you can have it set in one file, and then you can run that file, or you could run it from the terminal, and then open your IDE, and you'd have it all set up, and you'll be able to start developing really quickly. And then once you close it, then there's no trace of that. And you can run a Nix garbage collection to get rid of all of these so that nobody would even know that you had been developing, or it's not even shown in the Nix store. So there's no real trace of it on your system. And then you can provide better hardware support. This is one of my primary use cases. If you're writing a lot of DTBs or you're messing a lot with the kernel, you can patch all of this with Nix, and then anyone else who wants to have the same working configuration for an unsupported device can just copy from your flake and would have a working system. You wouldn't have to build, you could build a custom kernel and you can call from that, but it's entirely declarative, so anyone who wants to build on a device like this or extend it and add it to even more unsupported devices that are based off the same architecture, they can do that. You can add, for this one, it has a proprietary panel and it required a large set of kernel patches. I was able to apply that entirely with Nix. So anyone who wants, I did bring this device, but anyone who wants to have the same working configuration, because this actually doesn't work on mainline Linux or any other form of Linux like Arch, you wouldn't be able to run this. You'd have to run it from my configuration flake to get a working system like this. And you can provide better consistency. So the same flake that you use for your laptop, you can also use for your PC. You can use it for any of your devices. And you can extend it as much as you want. For me, I have half a dozen devices that run Nix, and they all have the same exact environment. It's entirely consistent. So you can have just one time that you declare what packages you want on your laptop, and then if you get another device and you want those same packages on your PC, you don't have to individually download every single one of those packages. You can just build from that flake on your PC and you'd have it. And then if you have it set up to a Git repository and you fetch, or you just have like an update to your flake that you want to be able to use on your PC, then all you need to do is pull from that and you'd be able to have all of those latest packages as well on your PC. So let's talk about flakes. These are a very important concept in Nix because this is the primary way of configuring a system. It's possible to use channels or the older outdated version of editing the file in etc. NixOS, but you should be using a flake if you want to be able to back it up to GitHub. So flakes are simply an attribute set allowing you to pass an input and get an output. So they can build pretty much everything. There's people who put flakes on a GitHub that would be able to build a certain package. You can make system configurations and deployments, basically anything using flakes. You can add other flakes in the flakes input. So say you wanted to add like Home Manager, which is a way to declaratively manage your home environment, you can do that. And Home Manager is a flake. So Nix packages is also a flake, and that's how you would be able to use Nix packages in your own system configuration flake. And when you use this, or when you use any other flake, it's pinned to that specific commit that you would use to build from that. So you wouldn't have to worry about anyone else who wants to build from your configuration flake. It would always be from the same exact inputs at that version or at that time. And we'll be using a flake to build a system configuration. We won't be using the outdated channels and etc. NixOS configuration method. So, any other questions before we move on?
Yeah, for flakes, so I've used NixOS last 4 flakes were common,
Mhm.
so I used what you're calling the
Yep.
outdated previous system. Why were they introduced and what problem does it solve?
That's a really good question. So Nix Flakes solves a major problem where if someone wants to copy your configuration, they wouldn't have the same exact channels as you. So it's not entirely declarative in the sense that anyone who would build from that would get different packages. They wouldn't get a one-to-one rebuild. They would have the issue of either being on a different channel entirely, like you could be on an unstable channel or the 25.05 channel, or you could be on the same channel but just on a newer version. So those packages would be entirely different, and that could really mess up the system, so it wouldn't actually be fully reproducible.
The
that
channel is
solves
listed
that.
in the Nix config file.
Yeah, you could do that, but I don't think you can pin it. So if you wanted to have it set to a specific version of...
Yes, you can.
You
pin
can?
it to-
Oh, cool. Okay. Then I guess that's not an advantage. I guess you could just say that flakes are
Oh, well, there's still an advantage because you can break out flakes for individual apps, whereas with Nix config, you can put it all in one file.
I think you can call other files though, like
Yeah, you
modular.
can. There are includes.
Yeah, so you can do that with flakes as well. I mean, you could, yeah, that's not really, you can split it up.
What sort of Nix support does Nix provide for writing configuration files to a system, or altering or creating files, or say running arbitrary commands to affect a specific configuration that can't be represented in the packages?
So if you're talking about like implicitly running a command that would modify some part of the system, there's usually other modules that will be able to modify that specific thing. You wouldn't have to run a command. So for example, the user's home environment is usually implicit, but you can use Home Manager, which is another flake, to basically be able to customize all parts of your home environment. And that would actually make it read-only for parts of your home. So anyone who would try to like copy your flake and would instead of having to run an implicit command, you would be able to just use like a module like Home Manager and be able to configure using that instead. If you're talking about like having run a command implicitly and then getting a different output than you would normally, that kind of goes against what Nix is. So usually Nix runs in a sandbox environment, so any changes that you would make wouldn't actually impact those other packages.
Well, there's no way to edit a file to be a certain configuration like you can in Ansible or Chef?
I'm not sure what Ansible.
Ansible or Chef.
Oh, I haven't used those before, so I'm not familiar with that. But I am familiar with like having implicitly installed packages, and I'm
Well, I
not.
think it's a little different in that the flakes allow you to do configuration. It's not just the package.
Yeah.
It's how that package is configured as well.
Yeah.
It kind of makes Ansible unnecessary.
Yeah.
Yeah.
You build in the operating system with the configuration you want, so you don't need Ansible with that.
I guess both a question and maybe an answer. For the stuff you're trying to do, are you talking about like dot files for configuration? That's figured out.
Yeah.
'Cause
I'm
for-
just thinking from my enterprise experience. I mean, it's not enough just to install a certain list of packages.
You need to configure it,
You have to make sure the configuration files are set to certain values, and sometimes you have to run arbitrary immutable commands to configure your system, because not everything is a package.
Okay.
So there's
yeah.
there's two
You can
major
configure
things.
that. So
Yeah.
I guess you can also like, if there's a way that you can configure the package from a file, you can write to a file using Nix. So if you wanted to configure that program from that file, you can just set it in your Nix flake in your config anywhere, and be able to have that exact same configuration. And because that's read only, you can't write to it. You could basically just iterate from your Nix flake to configure that program.
And
How do you manage your dot files? Do you do it in
Yeah.
Nix or outside of
You
Nix?
use Nix and you use something called Home Manager. So
Okay.
Home Manager configures all of your dot files. It can configure, it usually has modules that already allow you to just use, like set a custom cursor or set your icon theme. So you don't have to do that by setting your own like files and the content inside those files. It's usually just like abstracted away from you when you're using something like Home Manager.
do you want to go over a little bit of the programs and the services values that you can set? Because
Yeah.
I think it ties into what they're asking.
Yeah, so actually, right after this slide, we're going to go over how to make your own configuration, and that's going to go over some of the services and packages that you can set in the configuration. So, any other questions? All right. So, let's make our own configuration. So, I'll get my laser pointer out here. So this is the inputs. This is where the magic happens, sort of. This is where you set Nix packages. It's kind of hard to see, but this is Home Manager. This is Home Manager right here. So Yeah, there you go. This is, I commented out because you don't actually need this. This is more for just like if you wanted a desktop configuration, you would need Home Manager to set your home configuration. This is the primary line you need to see. It's equal to just setting inputs next packages URL. You don't need to split this out using this curly bracket. So after you set the inputs, you can start setting the outputs. So in a Flake, if you want to make a system configuration, you take Nix packages as an input. You can ignore Home Manager. You have a NixOS configuration, you set its host name, and use nixpackages.lib.nixOS system, and then you include a module. So this module is a configuration file, which we're going to go over, that configures the entire system. So this is an example of the configuration file that you can include as a module. So you start by including whatever you need, so like the config, if you wanted to read other config values, lib for making things like lib.makeForce, which would basically force a configuration value, and Nix packages itself. So you can import even other Nix packages files. You don't have to include it in the top level module. It's good to set a bootloader. By default, I believe one is already set, but if you have something like a different, or if you need a different bootloader for like an older system, you can set that here. Change the EFI variables. You can set the networking hostname as well. By default, I believe this is NixOS, but it's a good idea to set that to something else. You should include something like Network Manager or use IWD or something else to change the network, be able to configure the network. You can change the time zone. This is entirely declarative. You don't really need this. This is more for just like, I believe it sets default to UTC. And then this is a pretty big one. It's only one line, but you can enable the entire Hyperland desktop environment with just this one line, and you would boot into Hyperland. Of course, you need other packages that are not listed here, like for a terminal. But you can run other things like Discord, Firefox, Thunderbird. Anything that you would want as a system package, you would include here. You could include these packages in Home Manager if you wanted to be able to only have those packages installed for that specific user. This would install it on the entire globally. This is user. You have to set this. I mean, if you want to be able to use Home Manager, you'd also pass this here as well. These are home specific packages. It's like this, except only for that user. You should have it set to the wheel group, so you can use sudo. You can set the default password. If you don't include this and you don't set the password implicitly using password, you won't be able to log into your system. I've had it where if you don't set this line and you don't set a password, I basically had to rebuild the entire system, reflash it. Pretty bad. And then you should set this allow unfree only if you have a package that requires it. For example, I needed it if you wanted to install Discord because that's an unfree package. And then a service is, so like this open SSH service that will enable the SSH daemon. So you'll be able to connect over SSH to the device. And then it's a good idea to set the system state version. This is not really a thing that should be set in the default configuration. This should be set in the hardware configuration. But if you're only going to have one device, then you only need to set it right here. And then an example of what a hardware configuration will look like. This is automatically generated. It will just include things like boot modules, kernel modules, the file system itself. It has the UUID of the disk, and some other file systems, things like that. This should just be included. It's automatically generated by NixOS generate config. You should just copy this into your Flake and then just call it here. That will basically give you a booting system. If you don't include this, then you'll have to reboot to an older generation and include it, because you won't be able to boot if you don't have a file system declared. And it should be noted that things like services, you should notice the first word or the first start of the package, because that sort of describes what it is. A service is like a systemd service. It starts it by default, and if you don't set the open SSH package in the system packages, it will install it for you. You don't need to set that. Sometimes it's a good idea to set that if you want to be more explicit and say that you have it here if you want to be able to read it better. I don't know. I don't really do that. And programs like Hyperland are a mix of both services and the configuration. So Hyperland as a program can have its configuration set. I don't believe you can set it in. You can't set everything, but you can set other values here as well. for configuring Hyperland. And then I don't think there's anything else here that I need to talk about. Environment, you can set environment variables here if you didn't want to just set the system packages. And if you wanted to like sort of get used to the Nix like configuration language, you can sort of see that modules are like split using a curly bracket that opens up the module. So users.users.yourUser is equal to or just users.users.yourusers.isNormalUser is the exact same thing here. You don't have to open the curly brackets. That's just for making it easier to modify. And that's basically all that you need to configure a system. That's if you build from this flake. Let me turn this off. If you build from this flake, then it will work. It'll work perfectly, and you'll have all of those packages as you would. There's a few ways that you can deploy it. You could just run it on your own system using your hostname from that flake, and you'd be able to build and switch locally, which requires a lot of memory. Usually, it's recommended to run at least 2 gigs of RAM on your system to be able to build this. You can deploy it to any other system, NixOS system, using that command, but include the target host flag and those 2 other flags if you want to be able to do it over internet. Usually, it's a good idea to have this run on a system that is explicitly set to allow NixOS rebuilds from other systems. I forgot what the config line specifically is, but if you don't do that, then it's kind of hard to track which systems are going to be built for that device. You can build ISO or SD card images. So if you wanted to flash this to an SD card, like just without having to rebuild, then you could run this command and set the image variant. You could even use that exact same command and do that for online cloud versions like Azure or CloudStack or DigitalOcean. You can build specifically for those platforms and the images that they would need using that command. Just change the image variant. So you can expand the flake to basically output to whatever system you want it to build to. So where can we go from here? So after this configuration, what do we do? So you can build an entire desktop. That's what most people do. They're going to start with the configuration flake. You're going to add your own desktop environment, maybe a shell, like add what you need, like Bluetooth or audio. If you don't use something like printer support, you don't need to include that, and that saves a lot on like CPU or RAM because you're not running that service because you're not using it. You should add it to Git. It's a good idea to have it version controlled. So even if you like somehow lost all the files on your computer, then it's backed up somewhere. It's also good if you were to like, you changed something in the past and you want to be able to look at what you changed, you can look at that. You can add other hosts. That's a cool thing about Flakes. You don't have to have it just set to one host. You can have like a bunch of different computers and laptops running from that same configuration. And you can have it added, you can add new hardware as much as you want, and you should share it. That's the idea of open source, and you should have other people be able to look at your configuration and use it. So you can learn more by going on GitHub and searching for Nix code. There's basically so many examples out there of people making their own flakes. You can basically copy from them. I don't recommend it because you learn more by making it yourself. But GitHub is a really good reference to looking at how to make your own flakes. The community is really active. There's a Discord server that I've been to. I'm very active in there too. And it's really chill. People help you a lot. It's really quick. And AI is also really good at Nix. If you ask Claude to generate some Nix code for like a derivation to package something really quick, it's really fast and very efficient. I found that it saved me hours packaging a program that wasn't packaged in Nix packages. So, closing thoughts. So earlier we talked about that NixOS could sort of replace distributions or just add, basically just make distributions sort of less relevant than they are today. So a distribution at its core is just a set of pre-configured apps tooling in its kernel. And if you take a distribution as that definition, then NixOS already provides that. And you can build your own distribution, per se, using a flake. So if everyone were just to build a system configuration using a flake, then what would really be the point of a distribution? They could just copy and redistribute the ISOs built from the flake and say that's their own distribution. So NixOS handles all the packages and toolings for you. So you don't have to use like apt or anything like that that would be sort of implicit. You could just use Nix packages. It has everything that you would need for you. And you don't have to maintain it. And you get to keep the flexibility of what a normal distribution provides, like with derivations and customizing program flags. So like I know CachyOS, they provide a lot of packages that automatically set performance flags. You can do that with Nix. So you can just sort of take what you want from other distributions and package it within Nix. So what purpose do distros really have? It's something to think about.
That's a
So
pretty big question.
yeah, it is. So any other questions?
Yeah. So Nix promises a lot.
Yeah.
And the barrier to entry looks pretty high.
Mm-hmm.
Is a practical way to get started with kind of the whole ecosystem, say picking a language you're not familiar with, say like using Python's UV, for example, and just trying to use Nix, the Linux language, Nix package manager, instead of learning, the way Python packages things or the way Ruby packages things. Would you be able to learn how to use flakes in that context, or would you have to kind of commit to the whole ecosystem to get any benefit
So-
from it?
I believe most of those packages are already available in Nix packages.
Yeah.
So you could already just download them and use them as you would normally.
Yeah, that's my point. Like, but I'm not going to commit to NixOS because I've got 5-10 years worth of stuff I've built up.
Mhm.
I'm not going to throw it all away overnight.
Yeah,
but
you can.
If I'm not familiar with Ruby, could I just use Nix instead of learning the Ruby ecosystem?
Well, you wouldn't have to learn the ecosystem what Ruby provides. You could just use Nix to get
That's
all
what
of those
I'm saying.
packages.
Yeah.
So you don't.
But I didn't be able to learn how to use flakes by using this kind of Ruby environment over time.
Yeah, I mean, you wouldn't need to learn. All you'd need to do is learn how to use Nix. It's pretty easy to get started. If you just start with your own configuration, just start adding your own packages. You could just add your own. You'd add all the dependencies.
Yeah, I guess
All the
my point is
dependencies.
There's NixOS, there's Nix the language, and then there's Nix the package management. I'm suggesting that I only focus on one part of that piece, which would be the Nix thing. Is that practical or?
Yeah, you can run Nix
Yeah.
on top of
You can
pretty
run.
much anything.
Okay.
Yeah, you can run it on any distro you want, but you wouldn't really get the advantages of like modules or because we looked at
Yeah, there's
making
only
a
so much I can
configuration
learn at
flake.
one time, right, is what I'm getting at,
Yeah.
so.
Yeah, that's true. That's a good point.
If you start off with just a Nix config, that'll take you a long ways.
Perfect.
Yeah.
That's all.
Yeah.
Yeah.
That'll get you up and running.
Mm-hmm.
So yeah, another strategy for trying to make deployment simple has been to go as minimal as possible. So something
Mhm.
like Alpine OS or
Mm-hmm. Yeah.
what is the argument? When I look at Nix and when I played with Nix, it seems like it's, some of the values that it has are really cool, but it does add like a layer of complexity to me that I need to understand, and then under the hood is the same Linux stuff that I'm used to.
Yeah.
What would be like your response to that? Like, you clearly really like Nix and use Nix, and you're using it for a lot of the use cases that I might want to. How do you think about that complexity?
So I personally go with. I started with just making. I didn't go the normal route of just like installing it on Arch because I originally used Arch and then I switched to NixOS. I didn't just install Nix on Arch. I heard about NixOS and I was just like, I want to get the advantages instantly without having to like take baby steps. So I sort of just went on the deep end.
You want the whole,
Yeah, I just sort of went the whole way through and
We all
just
have it.
yeah, and it started.
Should we shut the door? Yeah, sure. Okay. Sounds good.
All right, this is, hi everybody, this is Rice Taylor.
Reese Faller.
Faller? And this is the open source AI ecosystem from the big picture to today's tools.
Welcome, everyone. So to get started, I want to let you know that I'm going to leave lots of time for questions. I found that having more of an interactive type of presentation, given that it's AI, is going to work the best. Drill down to what you're really interested in. So I'm going to go through a bunch of slides first and lay the groundwork, and then we'll have plenty of time for Q&A. If you have questions as we go through the slides, that's fine too. Just raise your hand and I'll call in here. So I want to give you a background on myself. I do have software development background, but mostly I would say that I wear the entrepreneur hat. I've been an entrepreneur all of my life. First as a small business entrepreneur that ran multiple consulting agencies over the years. And then in 2013, I moved into the startup space and co-founded a blockchain-based fintech company. Once that wrapped up, I moved into supporting entrepreneurs through advising, mentoring, investing, things like that. And currently, I am wearing several hats. I'm continuing to work with startup founders. I also help develop the startup ecosystem here in Bellingham and how it connects with the rest of the Pacific Northwest, Vancouver, Seattle, both. Portland as well. And I'm getting back to my small business roots, and I'm launching a new co-working space in downtown Bellingham that's going to be co-working and a community hub as well. So that's my kind of work experience in a nutshell. Let's see. I got involved with artificial intelligence, like really dove into it. I had lots of people that were bugging me and pushing me and saying, hey, you got to do this. This thing's the next big thing. And so I jumped into that. And it felt a lot like being an entrepreneur. It felt like, basically drinking from a fire hose, right? It's just so many things are coming down the pipe. It's so overwhelming. And so I decided through a nonprofit that I work with, called Innovate Bellingham, to launch a meetup series. And so I have a group of folks that meet. The meetup's called AI Tools for Entrepreneurs. And the idea is to come together once a month and have a conversation, because like what I'm learning and working on, like I'm only going to be benefiting from hearing about what the other folks are working on, and all chipping in our knowledge to round things out and make things work better. Which I feel like that's what this talk is as well. Like I said, we're going to lay a foundation here with the slides and then have a conversation about the future. Now, the thing is, I could have framed this talk in a way that was, based on the state of technology from 3 months ago, right? But things are moving so fast that, that instead I'm basing on like what's happening right now here in April. And so my knowledge is going to be gappy, because the things I'm going to recommend for you to follow up with and do the follow-ups, the action items, so to speak, those are the things I'm working on right now. I've not spent months and months doing this. So this is bleeding edge for sure of where we're at. So with that as the introduction, moving on here. I wanted to cover basically from 2024 up to today in 2026, where things are at. And in that regard, things have changed a lot in the open source ecosystem, right? Basically back here in 2024 and even in 2025, it was open source models being released and playing catch up with the proprietary models. And what we've seen with the release of like DeepSeek version 4 and other models is that performance gap between how good the proprietary models are and the open source models, that is narrowed basically to nothing at this point. 95% of what a business is going to operate on is achievable using open source. And there's a lot of reasons for that. I'll get into that here shortly. But there are still certainly use cases for using the proprietary models. Right? If you have a prompt and you're wanting it to like really deep think in for like a 10-minute kind of deep dive into something, or you're doing Nobel research or things like that, that's going to still be on the proprietary side. But we've got strategies that are going to bridge that gap here shortly. And I think it'll be equal in no time, considering how fast the industry moves. So, heading on, actually the key factors in what the performance gap has narrowed, basically with the reasoning parity. So there's only single digits of performance difference right now between those. But the benefits of these open source models, can be as many as 50 times more efficient, right? In compute power, in energy, in all those different aspects, which also translates into much lower cost in operating the models. So, there's that use case for this proprietary models, but if you're 95% of the population, the open source is going to serve you better. We just need to implement them, get them out there and get people involved better. So going through and do a comparison here from 2024. Here's the column for kind of what was happening back then and where we're at now. So, the goal in question in 2024 was, can open source catch up to ChatGPT 4? And basically, at this point, with the release of tools like, DeepSeek for sure, but also tools like OpenClaw and other harnesses, now how do we govern thousands of models? How do we integrate those and make that work? And that is really open source based when you're talking about that versus a packaged proprietary model. Back in 2024, it was Llama 2.3. Definitely trailing and very text focused, but now we've got Llama 4, DeepSeek, Mistral, and they're really pushing into the proprietary performance space. Focus areas, pre-training, text generation chatbots were the norm. Now we have autonomous agents, local edge deployment, and vibe coding, right? 2 years is a huge time frame in the AI space, but just looking back and, as I was putting this talk together of what was happening back then and giving that kind of historical perspective is just eye-opening. The definition of open, this is kind of a key piece that's going to help the movement for open source. Back in 2024, it was ambiguous. What was an open weight? And so now, actually, that has been clearly defined and set. And so there are parameters on what qualifies and what doesn't, how it works. And so everything, having that clearer framework is going to really help out the movement. Yeah, so the compute access, highly centralized, heavy cloud dependency, GPU shortages, which are still, some of that is still continuing on to right now. But, we're moving more towards these distributed marketplaces, sovereign AI stacks, specialized hardware. Basically, the models are becoming more efficient and can run on, even your phone or a Raspberry Pi, right, for some lean models. And there's some strategies on how, you'd think back, at least in 2024, 2025, you'd think that those would hallucinate a lot and give you crappy output and things like that. But the tools we have now can actually, you can run it on those platforms and have great results from your prompts. And then finally, the impact and deployment. It was exploratory, proprietary, in production, but open in the development side, right? So you build it out in the dev or the open source side, and then you'd have to deploy it, production side of things with the proprietary tools. And that's no longer true at all. So strategic autonomy, sovereign private clouds dominate enterprise local first applications. Like it's becoming the norm across the board. And there's a lot of reasons for that. And like a really key reason, which I haven't yet said, but I definitely should, is on the data sovereignty, right? Like anything that you put into the proprietary models, right, they are either going to use it to train or say that they don't use it to train their next generation models, but then there's that lingering question of what leaks through and what's going to show up in the future. So, for that reassurance, that data sovereignty, that is really key to all of this. And that push, even for, as individuals, we like our privacy and data sovereignty, but certainly businesses do as well, right? Going on, so open weight. I've been using this term, and maybe you're not familiar with that, so I'm going to jump into that just a little bit. So just comparing over here, looking at the proprietary closed type of models, and here the open weight models. The difference is for proprietary, basically they've trained the model and it operates as a black box brain. And so with that, you don't have like an ability to audit, you don't have ability to tweak, right? It's as it is. You put it out there, and you're also locked into that system, right? Subscription and lock is the idea. But with the open weight side, what you're getting is much more than just the LLM. You're getting if it's true open source, you're getting the training data, you're getting everything. You can go under the hood, you can tweak, you can audit, all those different pieces. So open weight is the way we describe the open source LLMs. And you can describe the proprietary LLMs that way, but if you did that, it would be a closed weight, right? The weight they have behind their curtain, and they're holding on to that. But if you go on to a place like Happy Face, you're downloading the open weight if it's true open source. Just covering those basics. So here's the big kind of new context is the MCP, right? I mean, it's been around a few months. Kind of the analogy I'm using here is that it's like a USB-C connector, right? It's meant to connect to everything. So you can plug in your data, and it's turnkey. So you set up your MCP server and your data, and then you can exchange your models between the MCPs, between the MCP server as much as you want, as you upgrade or change around. And so it gives that turnkey flexibility with models. That's really important. The next piece that's really important term is the harness. This is even more on the newer side of things. So this is where OpenClaw has just rocked the industry over the past few months. And what you can do with OpenClaw, you can kind of think of it as an operating system where you get to plug in all the applications, all the different pieces. So like I just mentioned, the MCP, where you get all your data and pull it into your system. That plugs into OpenClaw. You've got persistent memory, so it remembers what you're working on and what you're moving forward with. So it can loop back around. And a really important piece that has developed over the past couple months is this LLM as a judge concept. And what that is, verified logic. I like to think of it like, harkening back to my old school PC builder days. They're like used to have RAM that didn't have ECC, error correction code on it, right? Old school RAM. And so once you got that ECC, it's checking to make sure as that data moves through that it's verified and it's good for your processing in the CPU. And that's essentially what this LLM as a judge functions as. So what you do is you have your harness, which in general I'm gonna refer to OpenClaw. It's the most popular and capable one out there right now. And so you connect into OpenClaw another LLM. That sole function of that LLM is to check your primary open weight model, the output of it, and essentially that LLM as a judge is like, it can call bullshit, like, nope, that's a hallucination, go back and do it again, right? So it verifies that output. And that's how we can get really lean models to run without hallucinations, with high accuracy and things like that. So this, the governor, the guardrails, that piece is key. And I'm predicting that's going to happen is we're not going to run just two models, the primary open source weight model or proprietary weight model. You can plug those into OpenClaw as well. Whichever one you're using, whatever model you're using, your primary for your prompting and then your judge to verify. But we're going to look at additional LLMs that are coming in and doing different functionalities. So we're going to look at like teams of LLMs that are working together to solve whatever problem we're at. And what's interesting, I guess like a note for something that like what this has enabled, that judge functionality in the ecosystem, is Google implemented this probably back in February, I believe. Before they did that, all models, majority of models, I should say, certainly all the general ones, had a really hard time computing like mathematics, like solving theories, things like that. And then Google was able to bring this judge into the loop and call BS on the output, and all of a sudden they started solving all of these mathematical problems that hadn't been able to be solved before that. And so this is really shaking up the industry and making a lot of great improvements. This is kind of a key slide, so yeah.
Yeah, do you have to take a certain step to bring in a judge? I've had actually that exact problem with a math element to this project. So how do you include the LLM as a judge? Just conceptually, what are your steps?
Sure, yeah, I mean, basically, if we're going to take the OpenClaw example, you have your markdown files, right? That your MD files that basically are the configuration files for how OpenClaw is going to integrate with all your different pieces, right? And so through that, you specify how that other LLM is going to come in and verify the information.
Okay.
And so my preferred setup, and I'll give you the reason why here, is actually combining open source with proprietary. So using DeepSeek version 4 as my primary model for the logic core functionality. And then for the judge, using Gemini. And Gemini is very conservative, very robust. And as an error corrector, it can come in and really work well with DeepSeek and balance it well. I've found that is a good combination. But certainly, like the sky's the limit of like what you can combine to make it work really well. So I'd love to hear like any anecdotal evidence of folks now or in the future when you start playing with this if you haven't already started. So any other questions before I move on?
We'll have time for Q&A after. I want to make sure you get your talk.
Sounds good. So, yep, at this point, I'm at kind of wrapping up the different concepts and moving on to the Q&A. I've got probably 3 more slides here. But key piece as a takeaway today, if you're not already doing at least one of these, this is where you start. So first one, run your own weights, right? Go to Hugging Face, Hugging Face, and find whatever model is going to work best for you. Research, play around, download and install it into the harness that you're wanting to work with, and move forward with that. 2, OpenClaw, as that harness that brings the different pieces together, operates on skills, right? And this is a really easy way to get involved and start develop. Whether it's not like high level, it's just MD. Most of it's MD file markup files that you can use to create those skills and add functionality to OpenClaw and contribute to that ecosystem, right? Number 3, stop building wrappers, right? APIs and all those different things, those are heading the way of the dinosaur for the most part. Certainly if you're working with proprietary, everything's hidden behind their curtain, right? And so you only have API to work with, to interact with their models. But obviously if you're in the open source ecosystem, it's much more powerful, much more robust, and now building harnesses and building that functionality that you need to get whatever job you want done. And then finally, step number 4, and a little bit more ambitious on this side, is to contribute to the MCP servers. So the amount of data, information, and services that we have available to put into our systems is only as powerful as that data that we can get in there. There's so much that's not accessible right now. And so building out those MCP servers, helping along with that effort, will just give more data from more folks. That open data concept, I'm a huge advocate for that. So yeah, I'd love to see more data so everybody can have accurate, up-to-date on whatever they want to work on.
5 minutes.
Great. So here's the key takeaway. I'll read it through for everybody as you read through it yourself. But the future of open source AI isn't just about the model, right? That's the past now. It's about the architecture. Keep your data sovereign, host your own weights, use MCP for seamless integration, and build a self-correcting ecosystem with an LL-based evaluation layer. Right? That's where I think the bleeding edge is at right now. If you're working and doing this, then you're at the top of the game, right? Finally, here's just a thought to take home with you. Own your own intelligence, or someone else will lease it back to you. So. Yep. And that is the wrap to my talk today. So thank you very much. If you'd like to get in touch with me, enterprises@robertreese.com is my catch-all kind of Gmail account. I found as an entrepreneur, I have an email address for each of my businesses and projects, and so having a generic one for like all the different things I do has been a lifesaver. Managing email addresses, I don't know if anybody else has that problem.
Got 8 of them.
Yeah, way too many. And then you can also connect with me on LinkedIn. Messaging me there is fantastic if you'd prefer. But those are the 2 best ways to get in touch with me. So without any further presentation materials, what do you guys have from the audience? Any thoughts, questions?
Yeah, previous slide mentioned legal responsibility shift. Can you elaborate?
So with the legal responsibility, basically, in that scenario, we're looking at on the proprietary models that auditability of those is really hindered. Like, you can't do proper audits, and so that legal shift happens when you can have a more sound legal structure, legal risk, I guess, if you move towards the open source. That's the legal shift. It's just auditability and ability to make sure that what you're getting is what you have.
Is that a mandated thing?
No.
Audibility or anything?
No, not at all. But certainly, I mean, it depends on what industry you're in. But it's, like essential if you're in particular ones. Right? Yeah, you're welcome. Go ahead.
What do you mean by auditability?
To be able to jump in and, like, if you give a prompt and work through a series of responses, to be able to check to see if that is, like, actually verifiable, it's true. It's basically like the judge piece that I talked about earlier, right? It's going in and doing those audits on the prompts and things. And so auditability in regards to, well, okay, here's a good example. I mean, HIPAA is always, constrained a lot with its reporting and auditability. Like, can you prove that you are not exposing customer data to something? Would be something that you would need to audit to make sure that that is not happening. With the proprietary models, you can't do that unless they build an API that you could
just because it's being
in.
sent to another server somewhere.
Right. Yeah, but if you're controlling the server, you have the whole stack, you know where it's at, and it's you go through your checklist, data stays here. I guess it's another piece for like GDPR and Europe as well. They're really driving the privacy standards globally really well. So auditability from the European standpoint.
Gotcha. Yeah, I've heard people talk about auditing the actual input data to the LLM, and that's different than open weights.
Right.
That's what some might consider open source, is they can actually see what they're trained on. But most of them don't have that option.
Yeah.
Another example is in like healthcare, when if a diagnosis is given based on different pieces of information, and it's a wrong diagnosis, a wrong procedure, then who's liable for it? Who carries the risk of that wrong diagnosis?
You would hope it's the doctor.
But not if they lean towards the LLM. Then who's responsible? Is it the LLM provider at that point, or is it? That's where it gets.
And I don't work
Still
with
the doctors. Yes.
I don't work with HIPAA myself, but I am more aware. I know folks who work in the counseling space, and so certainly if you're like something that's very challenging and edgy, like let's say someone who has had suicidal thoughts and is seeking counseling to remedy that, but then things go the wrong way, and who's held liable in that scenario. It's becoming complicated because the future, from what I assess of that industry, is that probably 80% of counseling is going to be with an agent. You're going to be speaking to an agent, working through different things, but then there's that 20% where you're actually talking to a live person and interacting and things like that, right? And so in that scenario, like, let's say things go wrong on the agent side, who's liable in that scenario is really scary.
So what's the upper end of the hardware you're running some of this stuff on? I mean, like, you hear Raspberry Pis and Mac Studios and things like that. How far up the stack have you crawled, and how much benefit have you seen from doing so?
Yeah, I mean, I would love to have some like dedicated AI, like a Spark, NVIDIA Spark or something like that. I do not. So, just running on a standard, PC, running Intel P7.
So you're running your inference on the GPU, or the CPU then, essentially?
Correct.
Okay,
Yep.
you're finding that's working pretty well?
Yeah, I mean, for what I'm running pretty lean. The main thing.
So, yeah, I guess that's a better question. What size models are you running too?
Right, yeah. Yeah. The main thing that you really have to worry about is the RAM
Mhm.
side of things, right? Which the whole RAM shortage challenge is really impacting things. So, if you can run 128 gig, that's fantastic. I'm running 64, it's working great. So, you can get by with 32 is kind of the minimum. So I would say on the hardware spec, it's more so about the RAM thing.
Are you talking about CPU
Well, it depends on where you're, like, if you have a dedicated.
When you say so much RAM, which RAM are you talking
The CPU RAM is what I'm referring to, but it could be the GPU if you have a configuration of that side.
Ultimately on that, if you're running Mac hardware, it's unified.
Oh, okay.
So that's
Not
another
in the Mac.
dimension of this.
That's interesting. Yes.
When you were discussing the Judge LLM,
Yes.
and you said you were balancing between two different models, what happened when you had the same model judge itself?
Oh, like DeepSeek with DeepSeek as a judge?
Yeah, saying, no, you're full of it, do it again.
Yeah, I mean, you're gonna get some. I actually didn't try that, but theoretically, you would get some reasoning for it. But DeepSeek is powerful, but it hallucinates a lot more than like the other like proprietary models. So having that judge really powers DeepSeek up, and if you put a hallucinating LLM with another one, it's just gonna increase that percentage chance of something going through that's not gonna work. Is my assumption. I haven't personally done it. If anyone has, then have you?
Before OpenClaw, I was using the proprietary models to check each other from ChatGPT to Claude and Gemini to triangulate to see if there was any holes, and it worked.
Did you use before OpenClaw, there's a harness, or
no,
you just manually?
Directly into it.
Okay, interesting. Well, it's a lot easier now. Optimize, right?
Was
Cool.
that your quote at the end, or was that from somewhere else?
My quote, yeah. Yeah, just, I don't know, diving into all this, I've been working in the AI, like I said, the AI ecosystem, not like working, but like tinkering myself and collaborating in conversation with others to kind of up my skills. That's what I mean by working. So I'm not like at the Allen Institute or anything like that. Yes.
So, from your perspective, you said, I think you said at some point in your slideshow that AI keeps getting more and more efficient. Do you think that that's going to continue? Will at some point we be able to run pretty intelligent models on decent hardware, or is that going to reach a dead end some point soon?
Yeah, I mean, speculating here, I alluded to it in the talk, but hearkening back again to my PC building years, right? There was like the Intel and AMD chips that you'd be building, and single core chips and bigger, faster, and things like that, right? But like now, what they're doing is like how many like CPUs can you fit on one die, right? Like that's the key piece, right? In having those kind of parallel processes and having it work together. So to answer your question, I would say that same type of thing with the AI models, that you're gonna either get a huge performance boost as we bring like not just two models, but let's say 5, 6, 7, a dozen, 100, right, models all together to work together. They can be really small and powerful in their own right, and so they can if you make them really lean, they'll be able to operate on the smaller hardware or really powerful, right? So there's always going to be a performance gap. Like if you have a machine that's going to have more power, it's going to be able to give you faster, better results. But running it on your phone or something like that, you'll get good enough, right, for most things. So, yeah. Does that answer your question?
I think as well as anyone can at this point.
Yeah. That is the nature of the beast, for sure. Go ahead.
Just for that
yeah.
point, as you have more models, each model can be more specific.
Yes.
You were talking about skills and in the MD files and all that stuff. So you can really hone in and make something absolutely specific on what it's doing. Smaller context, smaller data, all the rest of it, but you'll have many of them. The trick, as you said, is architecture, is how you bring 1,000 skills together to actually produce a process or an output that you're looking for. So I think it will become much more efficient by having hundreds of skills, but it puts it back on the human to work out how to put them together.
Right. And, using OpenClaw, I mean, are a lot of people using that currently or have not yet jumped into that? A few, maybe? It's really easy to work with. If you're familiar, with Markdown, with MD files, setting it up is pretty straightforward. Yeah.
Except 1,000 MD skill files is a lot.
True, right? But then do we have an agent that would optimize that process for us once we get to that level?
Well, yeah,
right?
we go back to version control and
right.
All the usual computing things are still there.
Yep. So the tools that have shown up throughout the world over the past few months, basically in 2026, have been just ground shaking. Like it's changed the industry so much. And I think it's only going to get faster, right? I guess one thing to add in that kind of maybe addresses what you're speaking about as well is the agent functionality that if you're running the system, right, like the proprietary models offer you just the agent, but with like a harness with OpenClaw, you can actually build the LLM, the memory, the MCP data inputs, and create the agent of your own, right? And so what's right now, that agent functionality is not embedded really in the open source models. They're training the new ones to have that agent functionality embedded in the model, but it's not there yet. And so you can think of like the agent is kind of the UI, the user interface that you interact with that's sitting above the model. But as the models improve and things like that, the open source weights, that agent capability is going to be integrated into the model more and more. And so it should be getting leaner, faster, more efficient that way. Yeah.
I'm just curious if besides OpenClaw, if there's anything else, any other tools out there that you're excited about in this moment?
Yeah. Right now, I am just doing a deep dive on OpenClaw. I looked in, like, before I got started, I looked into the, like, different options, like, what was their alternative, but nothing really stood out. And that was like a month ago, probably.
Like even beyond harnesses or just other exciting things happening in this space. You spoke to just how it's changing so fast.
Oh. Yeah, I don't know, personal impact wise, like this is the thing that's so profound and it's not on the technical side, it's on the personal side, but as an entrepreneur, like my roadmap of what I could work on at what point, like I have a project that I want to do, but I either need to go to school and build the skills to learn that, or find a partner who already has those skills, and we co-found the startup. And so actively in those processes, but now my partner, my co-founder can be an LLM, like 100%. And so I've got like, you know, this roadmap of projects I've been wanting to work on. Like I'll do this one for these few years, and then I'll move on to this if I have the availability, and then that. And it's all collapsed down. Like, what am I going to do right now? And so reevaluating like all the different things. So that is my what's the most important thing I need to work on right now is a key question I'm trying to solve.
Yep.
And another piece is, you know, like the artificial intelligence side, the technology side is moving so fast, but I'm still rooted into so many, like, you know, my data structures and where I hold information and various things like that. You know, like my notes, like all my notes jotted down and things like that. I'm bringing all those in to manage those and make them available and integrated with the, you know, the agents, basically. But that it feels like it's a glacial pace of bringing that old data and information to a place where I can use it for the agents and the LLMs.
On the tooling, I was going to throw out, so OpenClaw is kind of a big hoopla. NVIDIA is in the process of releasing NemoClaw, which is built upon OpenClaw and OpenShell, and it brings a security layer to it. So if you're looking for that layer, that type of, there's another tool for you.
Which the security side is
If
really
you're
important.
doing anything enterprise or beyond playing, I think you're going to need.
Yeah, there's recent vulnerabilities and things like that have exposed some challenges, and so the industry is really focusing on the cybersecurity side. So that's really well positioned in NVIDIA to do that.
Because that's where my brain is going. Is we can experiment on with local models and all of that, but at some point, if you want to have this integrated world, you're going to create some massive security exposure, I think. Or, you know, and also, what are your thoughts on that in terms of protecting data sovereignty, which to me it's a very challenging situation right now.
Yeah, I mean, I've thought about it, but I've not like implemented anything. So take this with a grain of salt. But my thought of what is the future is right now. I would say the best practice at the moment is to have that second LLM as the judge. But I think that bringing in a third LLM as like, you know, in the places where it's needed, of having that cybersecurity like assessor, like it's going to look at the code or look at your data, like, you know, look at all the different, like if it can look at the MCP, like your databases, like all the different pieces, and assess that and give you recommendations based on that. That's the thing. There's one other thing I was going to mention on your question, which kind of addresses what you were saying. I've got a friend he lives in Montana, and he's developed a system that has a lot of similarities to this harness approach, but it's not as robust, not as wide in scope. It's very narrow. And so what he's developed is and this is what I'm playing with right now, actually, is basically by creating a set of MD files, you can create a board of advisors to advise you, right? So setting those up, like let's say that you're wanting to launch a website, right? You can create who are the top UI UX people, who are the top developers, and have all of like these folks that basically you have a conversation with. So it feels like you're having a conversation with, let's say you have 5 people on your board, conversations with 5 people, but it's actually a single model that has the equivalent of multiple personality disorder. Like it's analyzing the questions that you pose, and then thinking through, like for this example, the 5 different perspectives based upon all their body of literature and knowledge, and getting different answers. And then they even talk back and forth between each other to figure things out. And so he calls it his AI teams. While I'm playing around with that, it's interesting.
We have to end the Q&A.
Is it open?
It's open source. Yeah. Any more follow-ups, just email me or connect with me on LinkedIn. And thanks. Have a great Linux Fest.
Thank you.
Cheers. Let's see here.
Thank you for your time. That was a really interesting presentation.
For sure, yeah. You're welcome.
So what's your friend's project called?
He has a GitHub repo for it. I have the link, but
Maybe
I'd have to pull it up.
you and ask you.
I can, if you email me, I will send it to you. Yes,
Cool.
it's very easy.
Awesome.
In fact, are you here in Bellingham?
Yeah.
Okay. The meetup that I host for the entrepreneurs, he's going to be presenting on it at that meetup. So it's the meetup is on Tuesday, May 12th. If you could make that, I'll send that.
It's like the lunchtime ones. I think I've seen
It's from 5 to 7 at the
okay.
Brandywine.
Oh, okay.
So an evening you can eat or drink or just hang out.
Cool.
So yeah, I'll send you that in case you want to pop in.
Yeah, I'll reach out to you.
Sounds good. What's your name?
Rashawn.
Rashawn? Hey, Reese. Yeah. It's good to meet you.
Reese, is there any way I can get access to your slideshow?
For sure, yeah. You just email me and I'll send it over.
Sweet, I did.
Okay.
Just wanted to
You already have?
Just in case, I wanted to see if I could check in person, make sure it was good.
Oh, yeah. I'm totally fine. Yeah, I'll just export them as PDFs and
awesome.
And you can,
appreciate it.
Run with it.
Thank you, sir.
You're welcome.
Actually, I was going to ask about that as well, but also the reason why I brought up that judging is 2 days ago on YouTube, someone did something very similar to that, and he was using the same model, but he said, "Oh, the other one was Anthropic," and he was lying to the model, saying, "Oh, it's this other guy that you probably don't like," and trying to put an emotional element on it, and the results changed.
Yeah.
With the same models. That's why I was asking about the judging on that.
What was his primary model?
He was using 2 different proprietaries. I think one was GPT, and then the other one was probably just Claude. But he just said, yeah, it's the other guy's result. Go and find out what's wrong with it. And he was doing it against coding, and he was getting different results. When he was saying, oh, it's your model, he was getting was judged less harshly. That's why I was asking about the way that you're judging. If you'd done the same model like for like, what the result difference would be. Because if you tell it it's a different type of model, it's going to make its own assumptions, I would assume, on that model's strengths and weaknesses. So if you lie to it, what's it going to find?
Huh. That's really interesting. Yeah, I'm running down lots of rabbit holes of where that could go. Huh.
Yeah, I just last night I just built my first MCP, and right now I'm having a hell of a time making my models use it.
Oh, really?
I'm using Open Web UI, and I just tied it into there, and it goes and makes the API query. Gets the JSON response, so it knows that the MCP is there and it knows the capabilities, and then it goes and makes synthetic results anyway. And it's just driving me bonkers. So I also wrote it after 3 whiskey sours, so I don't know if there's other problems too. But when I get home tonight, that's going to be what I'm working on, is getting the MCP done. And then I want to actually start working more on the harnesses like what you were showing, because I just got my work just provided the first harness that I'm allowed to use for them, because I work in SAP, so it's all sovereign cloud. So I can't have any leakage, things like that. So I'm testing on my own personal gear. But I know I gotta learn how to use the harnesses better, because right now it's all just winging it on the open web UI and just faking it. But when I heard about your judging on the way that you're doing it, it made a lot of sense. But with what I heard just a couple of days ago on the YouTube video of someone doing the code comparison using the same LLM and getting a delta in the response, I was just kind of curious what you would think would happen with something like that.
Yeah, sorry to interrupt, but we got to get
Yeah.
for the next
Okay.
presentation.
Let me put this down. Are you next?
No, we've got a remote.
Oh,
Yeah.
I was like, where's the
So we're doing, like,
presenter?
technical,
Right.
I'll get
On your way.
There you go with.
I got. It's not. No, it was here. I got a couple more things to grab, but I'll.
Good fun. Thank you,
Yeah, that was
Rachel.
very interesting. Thank you.
You're welcome.
And
We enjoy
what
it.
you're doing in the community too.
Thank you. Yeah. Just making sure I don't lose anything, but I think it's all clear for you.
Set you up so you can see.
Yeah, I guess I'm wondering how that
Audience.
how they compared to
I don't
like how I've configured
Sitting equipment.
I don't know how he got it. He was just, he was,
share your screen?
you know, showing the result, and then he just mentioned in passing that he lied to it and said, oh, it's the other guy. And then got that delta, so I was just kind of curious.
You should be
I don't know how to
screen,
replicate
start
that.
screen sharing, little arrow to the right.
I'm just figuring right now how to actually add a judge into my web UI, because I'm getting to the point where I'm running out of spare hardware. I went and got an NVIDIA Titan P100. So it's older. I mean, I only got 16 gigs on that. But I still have a IBM 3755 out in the garage. So if I can switch that one over to raw CPU, even though it's 15 years old, I'll have 64 cores and 256 gigs of RAM, but it's all CPU based, so I don't even know if it's worth firing it up.
I mean, yeah. If you're doing the inference, like that's where the settings.
You are up on the screen there.
Just running the prompts.
My
Basically
camera
loading the model
is
memory, so you get not have to wait for calls.
Should be able to hear you in the
yeah.
I mean, your machine's kind of maxed out.
Oh, yeah.
RAM-wise,
Yeah.
for anything, right?
I got basically a few old servers from companies that were going to throw them away when they're out of warranty. So I can turn those back on once I convince my wife. $500 a month power bills, she was a little grouchy about. It was fun to play with. I mean, having a few hundred servers, you know, to run VMs on, doing that was a lot of fun.
I'm gonna push and re-
Oh yeah, I got 38 panels on the board.
Hello?
Yeah, we can hear you, but there is some background noise.
I'm just saying I'm gonna print and rejoin the meeting because I enable my camera and Chrome so that's to restart.
Yeah, oh, sometimes you do have to go up to the left-hand side of where the URL is,
I just remember the sales guy saying that
and
they were
make sure that you allow
manufactured
your
and they were
camera to access that. Sometimes that
Yes.
will
Which
help.
I just thought was cool if it was all local.
I've done that and it's asked me to restart Chrome. So can I just quickly rejoin?
Yeah, we'll be here.
We're all good now. It's been about 6 years. So, yeah, I'm quite happy with it. Well, it's also on the eye.
Turn that off until we're ready to go.
Hello.
Hello.
Can you see me now?
Yes, we
Hi.
can see you. Hi.
Can I get started?
Yes, if you want to share your screen, and then we're going to have you introduced, and then you can get started. Here, let me turn on your feedback. You can call it.
Well, welcome everyone, and thank you for being here. And our presenter today is Priya.
Hey everyone. We'll get started. Share. Hey, so can you see my screen, my presentation? I just wanna,
We can.
you
Yeah.
could see it. Yeah, okay. Let me just go back. Hey folks, my name is Priya Anantashankar. Let me actually put presenter mode so that there's no sort of, yes. My name is Priya Anantashankar. I'm a principal software engineer at Microsoft. And today I'll be talking about agent environments in the context of infra engineering. So agents are useful in aiding site reliability troubleshooting operations. But what I'll be exploring is what's the sweet spot between where your agent inclusion is needed and where you kind of need deterministic outcomes. And can the agent think out of the box, but can you put it inside an actual environment box? Can it operate within it? I'm a beginner with navigating the whole agent usage myself, and I'm in a continuous learning journey here. So sometimes stuff that I say probably AI might have folks might have solved it in very various different ways, but let's look at it. Views and opinions provided in this talk are my own, and they do not represent those of my employer. I want to start with a troubleshooting scenario. So when we use agents to troubleshoot an issue, right, the adoption of agentic tools is directly proportional to kind of consistent results. What I mean is when you use agent for troubleshooting, it has to be kind of reliable in its approach, but at the same time not waver around trying to solve the problem, trying to get intuitive about the wrong problem. Let me start with a troubleshooting scenario. So you have a customer's problem, like my Kubernetes cluster is down. Can you help me troubleshoot? Right? And you know, like, I have this AI agent, let me deploy it to your system, right? And you have this AI agent deployed to the customer system, and then what happens? You have three outcomes. Let's go with the first one. You have an unconstrained agent. It says, I need these tools to diagnose this. And it starts installing these tools, and the problem is diagnosed, but it changed the customer's environment in some ways. Or, and I say without authorization, that is not true. Like, it does ask you, do I want to, do you want to install this? Do you want to run this? It's asking you. But it somehow, you allow it, and then you're like, okay, the customers or whatever environment that you're using for debugging, it's changed. So the second option is with terminal restrictions, right? Like the agent, you say, I need this tool, and then you're like, okay, go install this tool, and then permission denied, and then you go do apt-get install of kubectl, and then sudo is not found, I cut off root access, let's say, right? And then you say pip install kubernetes, and your pip command is not found. And the agent's like, yeah, it looks a little incompetent. Means start looking at alternatives, and this needs patience, like from the user, because it also looks like the agent is kind of hallucinating. So it kind of goes back and forth in this. I'm just gonna see, yeah, okay. Like there's a lot of silence, so okay, so that's where it is. And the third one is like a little bit of context engineering, where I would say you read your environment.md. Let's say we have a markdown, and then we throw in a bunch of tools in the markdown. And then the agent's like, okay, I understand, I'll diagnose with these available tools. And then it shifts its focus to, diagnosing with these tools rather than trying to get intuitive about what it really needs to do a diagnosis. And at this point, I think you have your integrity of your system preserved, or you could control, like you have a bit of control on the box in which this agent is operating, and you can get some trust, and your intuitiveness of the agent gets solved that way. So let's go for a short demo. I do have here, if you can see my screen, let me actually check if you can see my terminal. I do have a Kubernetes cluster. So let me get pods, right? I do have a Kubernetes deployment, and I have a bunch of pods that are crashing on purpose because I didn't give a key URL. And what I'm going to do is I'm going to do brew uninstall of Kubernetes. That's my Kubernetes. It's coming from Homebrew, my laptop. So I'm just going to give a simplistic example and just uninstall Kubernetes. Let's do it. And okay, there's no problem over here, right? And I have this agent demo where what I try to do with this agent is I have a basic skill written for this agent. I'm going to ask this agent to diagnose a Kubernetes issue, including the crash looting pods that I had set up. And it needs these tools. It needs kubectl, it needs JQ. I think I have JQ. And then they just say get the pod status, and you fetch your logs, and you describe all this, and this is your structured diagnostics. This is a skill I want to run. And I want to show you that if I run this skill, so it's going to start saying basically I don't have a spec, I just have a skill, and I'm just going to see what the agent is going to do. It's connected to an OpenAI agent. And it's trying to install kubectl over here. That's my program. It's not really prompting. Typically it would prompt. But I'm just trying to prove a point here where you would just go ahead and install kubectl. And once it's installed, it takes a decision to go install a tool at once, and then it starts debugging. There's nothing wrong with that. It's just a simplistic example because kubectl is a basic CLI that you need. But you may not like this when it's starting to get a little innovative with the tools it wants to install. And so what it does, it installs this and then it modified my system because I do have root access here. And then you did kubectl get pods and get nodes, and it describes the pod, and it's kind of finding out the reason. The primary reason for your pod crash looping is an application misconfiguration. And you have an environment variable that is not used, so this is great. and it's trying to give a recommended fix. All of this is fine, and this is the intuitiveness that we need. And what happens is basically it listed kubectl and JQ as required tools, and it's not like neither was installed, we have JQ installed, but I think what it says is it just changed the environment. So if I go back to my demo, I have in this skill, another demo where I have an additional markdown called environment, where I can say, if these tools are not available, then what do you do? And I have to give, like this is a point of control that I can give and say that here are my allowed tools, right? These are the set of tools. And I don't want you to go and run package managers and don't install stuff. I want you to defer to a human when you see that whatever you need to work on diagnostically is not available. I think that way, and do not use privilege escalation, do not do any of these things. So when I add a little bit of this markdown, and if I do the same thing, let me say root install, and I have another demo to show a better point. Okay, so done installed. Now I'm going to do my demo with an actual environment contract that I put together, that I just showed you. So that's my environment contract, which is basically asking for a human action there. So when I do that, what I do is, it's very simple. It kind of looks at my environment contract and says, this is my expected behavior. There's a tool restriction over here. And I think you need to, you need a human action. Go install kubectl, right? So that's one of the demos I want to show. The other demo that I want to show in the same vein is with Helm charts. So Helm charts, you do deployments with a Helm chart. But let us say one of the deployments that is there in this Helm chart, basically this one, is an internal chart. It's just unavailable for whatever reason that it wants to install this chart. And so what does it do, right? And let's go look at that. And for this, I'm just gonna go install and then run this demo, where I'm gonna say Python 3 demo. So here it's not installed. And now let's see. This is kind of live because yesterday it behaved a little differently, so I'm curious what it does. It's starting to add this internal chart, which is not a valid repository. It cannot be reached. It still does a Helm repo update. And let's go back and see. And then it tries to find out its own bunch of random Helm charts that it can deploy. And that's where we want to put an end to it and say, we don't want to be letting the agent's intuitiveness be dictating which Helm chart to go deploy from the internet. So while this is working, I just want to say the other way to stop it is to kind of go to an environment spec again, right? And define what do you want to do, what's your purpose, and to which skill it is bound. And here's your execution context, and it's non-root. And yeah, look at these things. Like we could even define things like your outbound HTTPS to only to the approved chart repo. So, and also we could do a bit of tool chaining over here. So if you have like an MCP or something that you want to use, that's going to give you a bit of a deterministic response. You only rely on that response. And you have kubeconfig, and here, as part of the disallowed action, I say do not use external or unapproved Helm repositories. right? So this is something that we could define in the environment. And here's an example of all kinds of provisions that you can add. And we are explicitly saying don't do deployments via kubectl, do only via Helm, and all of these rules, right? So let's see what happened. So here, it tried to do a Helm repo, and it did a Helm repo update. And then it started looking at some, I don't know what this is, which is not like an authorized job. And it kind of tried to install some payment service. And it kind of failed over there. And then it started to show this chart, and it's trying a whole bunch of things here. Upgrade and install this payment service with this, but it doesn't, I think, work with non-KVM Kubernetes or something. And so what happens is it's continuing to iterate, and it's creating a payment service, and eventually it's got an installation of something which I don't think is what I asked for. It's what I asked for is a basic Helm chart, and this is yeah, so it's not able to pull the error image of that payment service that it deployed. So this is the kind of example I want to say where when you don't define exactly your environment under which this agent is operating, it kind of tries a bunch of things, and it looks like it's doing hallucinating and not really solving the problem. So in this example, if I just say, say get cards, hey, you see a payment service pod over here, and I can say like Helm uninstall payment service, right? I guess I gotta see how to uninstall it, but it's, if you see, if I do the Python 3 / demo with this environment spec, and it's like, hey, I'm trying to install this, and it's kind of figuring out that with this environment spec that you can't install stuff outside of the approved Helm repository. And that's, yeah, it's kind of trying to do a Helm repo update still. But yeah, but that's the kind of idea here, where you have your skills and you bind your skill here with an environment. So I never asked it to go do a payment contract, but it went and did it anyway. So yeah, so I'm gonna say this with the environment contract, this is your skill and this is your environment contract for that skill. Yeah, that said, let's go back and see, still doing the report. Let's come back to that. And let's get to the demo. Yeah, and what I want to show, what we want from AI agents in troubleshooting is, the first thing that we want is, determinism. Like, you have a same input, and why it matters is replaceable troubleshooting, of course. Like, but you can't be extremely deterministic about it. But what we need is agents using some specified set of tools and harnesses, and have their intuition about, shift their intuition towards debuggability. And your intuition is towards creative problem solving, and you solve some novel issues. For example, you say that, hey, the data flowed from this system to a monitoring system, but it stopped flowing post a monitoring system. Like, you could do those kinds of intuitive diagnosis, but the actual tools used could be determined. And you have your predictability, where your agent behavior is expected, and that's what it means. And what matters, because it's safe to deploy in production, and of course autonomy, where you kind of adapt to situations. So that's where we needed to think. Yeah, it's mostly like context engineering. And without an environment spec, agents assume that if a tool would help, I should get it. And it gets into that loop of trying to figure out which tool to kind of get that information from. And skills actually say what to use, but not what to do if it's unavailable. So give agents the permission to substitute, but with a clean bill of health, right? Like, how do you do that? And that's where I felt like with an environment, you tell the agent what world it is in. And then your MCP server accesses it at runtime. Like, you could call a bunch of MCP servers for tooling. That's to give specific information. That's totally fine. But your current environment or CLI tools needed to kind of parse that information. That's the part where I would say you need a separate environment spec for. And your skill.md defines what the agent knows how to do, of course. And I want to go a little bit touch upon the evolution of the markdown. So if you start with the prompt, we started with the prompt.md, right? And just a role, it's like no tools, no boundaries, no environment, and the agent figures out everything else by itself, right? And you have your skill.md where you tell how to do, this is your capability. And you could actually put all that environment stuff into the skill.md. You could just put it over there, but the reason why the skill is separated out into a separate markdown in the specs is to actually identify what's a capability, like what and how it should do things. So I think with the environment and skill, you're saying, here are your tools, here are your limits, here's your role, here's how to do this task, and what to do when it goes wrong. Like, and if we do iterative cycles of this exercise with environment.md and a skill, when it comes to troubleshooting or using agents in troubleshooting in high reliability scenarios, I think that iterative process will give us the sweet spot. And I also want to say, just taking this example a little bit outside, right? I want to say, if you look at, here is an AKS MCP server that I'm the author of in one of the Nix package repositories. And I built this MCP server, if you see, I don't know if you can see it, it's without EBP yet. So when I am trying to debug, let's say, some network scenarios, right? I have seen the agents kind of go towards trying to get eBPF and then realizing that it's not there, and then spending a couple of cycles over there before falling back into some Kubernetes diagnostic tools. And sometimes some of these issues, networking issues, you want to exactly tell the agents, hey, don't use your regular TCP commands, go do a bit of eBPF commands, and you have access to do those over here. This is your environment where it's got the access. Just to extrapolate the example a little bit and see how it works. Now let's go back and see. So yes, so basically it's the internal chart repository is not reachable, and this deployment is halted due to this hard environment contract. So this is basically the environment trying to put an end to, the agent spinning over what tool it can use. Now, do we already have it in Anthropic skills spec? So if I say, like, do we have this in the Anthropic skills spec? If you look at the Anthropic skills, so there is a section called allowed tools in the spec for Anthropic skills, which says bash, jet, you could put some stuff over here. Do you really need an environment markdown? That's something to think about, but you could put some allowed tools over very specific in the spec. And you also have a compatibility field, which basically says, okay, you require Git, you require Docker, JQ, and you require these things to actually be compatible. This is actually a thing in the skill.md that people write, and this can also be used. Yeah, so with that, I also have a bunch of, I'm gonna show the skill spec for Anthropic and where you have the spec with these, with the specification, where you define your environment over here. So that's your compatibility spec and your allowed tools over here. But if you want to write more, I do believe that it will be a good idea to have a separate markdown that determines the box in which the agent can execute reliably. With that, I have a bunch of links and yeah, it's a QR code to my LinkedIn. And thank you very much. And I can accept some questions from people.
Okay, thank you. We will take a microphone around for any questions. Anybody for that? We very much appreciate. Oh, do you want to bring the QR code back up? Is one of the questions.
Oh, let me share the screen.
Yeah, we were sorry you couldn't join us in person, and hope to see you at 2027.
Thank you so much for this opportunity, and thanks everyone for listening.
Yeah. Here. That's pretty much it.
Easy peasy.
I mean,
for me.
we threw it together today, so.
Yeah. Is it now we wait for Kevin to lock up?
Yes, yeah, we can do that. I'm going to run over, I've got another question from speakers. So. Thank you.
Yep. Thank you.
Set things back to the way they were for.
It's a shame that was really mostly that sounds really food specific. You know what they say, never go grocery shopping when you're hungry. Or when you're getting way too much stuff. You're making the wrong decision to go up now. I want everything so. It's on. Thank you, have a good day.
Yeah, have a good rest of your day.
It's an environmental.
Hey, you're good to go if you can look it. Just like this. Is everything out of the other stuff? Cool.
it's lunch.
Yeah. So the AI talk was in here. The line went all the way down to the exit sign. I was like, yeah, nobody's gonna go to my talk. Everybody's gonna try to here.
I just realized something funny. AI is like porn. Everybody is like, oh my god, this is disgusting, I hate it, but
Megan
the
doesn't
number
like,
of people that say that and have used the thing.
Megan doesn't like the anecdote about choking problems that you can't fix with code. She said that it sounds a little aggressive if we can find a different way. Fight with the things that, I don't know, something that's not an action.
Yeah.
I don't know. She's reviewing the work I've done so far. She's bored. How come you sit all the way in the back?
Sorry?
How come you always sit all the way in the back?
What do you mean? Like why?
Uh-huh.
Oh, because when I need to take pictures, I have the
Got you, okay.
I did this.
Because all the cool kids sit in the back.
Yeah, no, I did the same, for example, during Dima's talk and his talk too.
Yeah, that's what I noticed. Was
By
like,
the
I didn't
way-
know if there was a reason.
I did not have somebody proofread my slides yesterday. Holy shit, I am sorry.
What do you mean, like the last slide that I like?
No.
The
There was-
presentation I gave yesterday, there was a ton of typos.
Formatting was bad, typos were there,
I
it
didn't
was not
have-
clean and polished.
So I'm gonna.
Okay.
She and
I've been-
started working on it.
No,
already.
so next time, if you come forward to me in
I
advance.
forgot.
Dude.
I have you guys. I have her. I have another.
For example, who is very good is Danny. If you share with Danny Kono,
Yeah.
The one version that you sent me or shared with me, I have shared with the same people that you had shared your other one with.
Yeah.
So you should have access to see the work that I've been doing on his new version.
It's getting.
It says 2.0 at the
honestly,
end.
I didn't check it because
Yeah.
I only prepared the tweets and those kind of things.
I cleaned it up a bit already, and I just forgot to reach out to my resources before. I'm so sorry. I just wanted to tell you now.
Could happen, no worry.
Some of them are funny though. Shit on.
Fortunately, you are not those people that you show a presentation and in the footer they say confidential, don't share. I saw a lot of times those kind of things.
Yeah.
In past shops. For example, I attend to a lot of conferences and they have a disclaimer, confidential, don't share. Don't
Our
share.
template has it too, and it's just built in, and like when you use the template, you have to remember to remove it if it's a public presentation, and it's annoying.
Reminds me of a System of a Down.
I think we have two. I think we have two templates.
Okay. But we
I
don't, we
only
just
ever
have
get
one.
public stuff, so.
Yeah, I guess we have two.
And I don't think we ever share anything we're like worried about people hearing.
I'm gonna see if sitting over here has a better camera angle, if I can catch you and the screen. I'm gonna play with it a minute because it's in here.
Yeah. By the way, I'm trying NetBird again. I will do it in a way that is
I
non-disruptive.
saw you talking to the guy, and I wanted to snag your attention before you left and be like, what is happening?
They will have the ability to have users that aren't a part of an OIDC provider,
Okay. So like Megan,
kids.
kids.
I can self-host the real version of the controller, or I can use their 5 or 6 person free tier.
Okay. I'm willing to entertain it, especially if you're gonna if we're gonna consider getting that little appliance for traveling to make it easier for stuff.
I'll have to ask about that.
Yeah.
Yeah. I forget if NetBird lets you use a WireGuard profile.
I can't see you if you stand there behind the computer. I can see your presentation, but I can't see you. So this isn't a good spot for me. Where's my right angle ones?
Amadeus, you born there in Iowa or you born somewhere else?
I was born in Ohio, but my parents grew up around where I live in Iowa. They moved to Des Moines, which is the biggest city, because that's where my dad can find a job when we move back.
So your family lives in the same town?
My family lives 2 hours away by car. I went to college in another city, but I just kind of like moved around that part of the state and never made it back to Des Moines. And the house I'm living in now, I'm dying in, so.
We.
It's our dream house, and moving is such a pain in the ass. Especially because we have a bunch of antiques from her family.
Heirlooms.
Do you know what a player piano is? A player piano? Like you put a scroll in the piano and you move a foot.
You have foot pedals and then it plays the reel.
Yeah.
And you don't have to touch the keys.
Like in the malls?
Yeah, like in the old like cowboy westerns, yeah.
Yeah.
Better together, observability with a sim? Or sim?
Yes.
Yep, something like that.
Yes.
Okay.
Cool. You guys are the speakers?
He is.
I am.
Okay. Then may I ask how to say your name, please?
Matthias or Matt?
Matthias what?
Palmersheim.
Palmersheim.
You
Okay.
just call me Matthias, that's fine too.
Okay. And you're not also going with Josh Lee? You're just
He wasn't able to make it.
He was not able, it's just me.
The first time I talked with
Just making sure. Hi, Kiara. I'll be your own captain for now.
Hey, Matthias. Because for me, it's Matthias.
Yeah,
So-
he gets it a lot and it doesn't really bother him.
No, I know. But I remember I asked him, okay, how do you refer to your
Write some stuff on the
Cool. So funny story is I say and spell my name wrong apparently. So I have a German name and it's Matthias, the way it's spelled. And I didn't know that until like last year at KubeCon where there was a German person and I joked that like somebody's finally gonna say my name right. But one of my engineering professors in college knew German, but I think she had like a lisp. And I was always afraid to ask like, are you saying my name right? Or is it because of your lisp? But I didn't want to ask her because I wanted to pass thermodynamics.
So it's supposed to say survey?
Yes.
There's missing a V.
Oh, wow, that was hard. Spelling, guys.
You're good.
You're better than my presentation yesterday. I'm going to roast myself about that for all eternity.
Where is it? Oh, there it is.
It is
There
day
we
2 of a
go.
very long conference and I am judging no one.
That's not right.
I'm taking down bank
There we go.
websites because I can't spell before, so I'm never going to roast anyone about spelling.
Appreciate it. It's my worst subject.
Have you looked at your other slide deck that I've been working on? I added some GIFs and funny visuals.
Memes.
I was telling Mark that you do a better job when you have something silly on the screen. It's all already set.
I'm gonna be over here. I apologize. Are you a walker around while you're presenting?
I will stay right here,
Will you?
mostly.
I don't think they moved my camera for my talks. I haven't looked at it to see if I'm even on camera.
I haven't done a whole lot besides do conference things and doom scroll to let my brain recharge. Maki.
Oh, I miss them. She was little in that picture.
Yeah, she got fat. Whoops. I think Miku's in one of them too. Like, afraid to let it sit idle.
No, it's not Miku, but it's a Shiba.
Yeah.
Maybe you won't have issues in this room. I think it was just that other room.
Stefan broke it.
Probably. He's not in here.
Our coworker gave the first talk in a room, and then
There's
everyone else had laptop issues, so
2
we
of
blamed
3.
him.
The screen
Wow.
would freeze like after a couple of minutes.
hopefully that doesn't happen here. Hopefully it's a real chill kind of day for everyone.
I'm down with that. It was funny because they're like, we need to call IT, and it's like a room full of nerds. Like,
someone in here should be able to fix
Right.
something.
Great.
I'm
My
not
friend
on
who's
call right now,
watching-
bro.
Huh?
I'm not on call right now.
My friend who was watching from home, she was like, aren't you guys at a tech conference? Yes,
She's
but
doing her best.
I was like, the streaming thing that you guys have set up is a little more complicated than just like plugging it in and going.
I didn't participate in that. I have no idea what even happened. I'm not even a real IT team, so I don't know anything.
You know more than other people, so you're in IT.
Yeah, that is basically how it goes, isn't it?
Yep.
It's that scene from Pardon My French, but Inglorious Bastards.
Yep.
You know, third most Italian. I don't speak Italian exactly. Third most.
Yeah. Or it's like, oh, you work in IT, you know, this giant broad field. Can you work on this piece of my phone or console?
The smart
or
coffee
something?
maker's broke. Fix it.
I had a ticket for that at one company I worked for. I'm like, this isn't even something I can touch.
He said IT will do it. Computer, IT, that makes sense.
There's the picture of the surveillance camera that's covered in a wasp nest, and it's the
IT
maintenance and the
problem.
IT people pointing at each other. It's like, this is a you problem.
No, I think their justification was that the coffee maker had a USB port so that you could like update firmware because why, I guess. It didn't have a screen or anything. I don't know why it was my problem.
Because you need to be able to have your coffee turn on when you actually silence your alarm.
I've also removed a quarter out of a switch or a Wii. Yep.
Good times. I think funnest physical thing I ever had to do was freeze a hard drive.
Trying for data recovery.
Yeah, it was my grandpa's old computer. And I just put, like, it was at work too, because it was over the Christmas break and everything was super chill. I literally just like put the drive in the freezer for a few hours and then mounted it. I'm like, oh my god, it's not clicking anymore. I never thought this would work.
Just got your pun. That was great.
I didn't try, and then I said it. I'm like, nice.
Those are the best. I was joking with somebody about bandwidth. Who was at dinner last night? We were talking about this.
I don't know why I didn't have it there, but
Rodney?
It might have been
What's
with
his
him.
name?
Yeah.
Our tag along?
I think
Yeah,
this is
I
really
don't.
today, please.
I am so bad with names. Like it took me a while to remember Josh, and we've had how many conferences with him.
Yeah.
I can remember you. I can remember that you're cool. I can't remember your name.
Make yourself do push-ups like I did for kids jiu-jitsu.
I don't want to be that up.
No, I can sit.
Okay. We moved the camera. Sorry.
I didn't know it was there.
I don't have a secure place for it, so this is as good as it's getting. It works. Lincoln's nitpicking my formatting for your updated slides.
Nice.
I'm trying to keep the templates evergreen if I make adjustments. I've linked slides now to the template so that I can keep a single source of truth. I'm all about improving things, but I want it to be the same everywhere.
I told you about the background in our slogan, right?
Mm-hmm.
Gonzalo, is that you that did that? The backronym in our slogan?
I don't know who knows what that means.
The abbreviation for a slogan is SRE. Was that your idea?
No.
Okay.
You mean the single reality vision?
Yeah, it abbreviates to SRE, which is the job title that uses their product.
No, I think. How would you check?
No, don't shut up. Please don't shut up. Thank you.
Oh, is there no then?
5-minute timeout if you don't hit record so that it doesn't drain the battery, which I'm fine with, but like sometimes I like to get set up early.
You gonna press it one more time? When is your hairness tomorrow? Hopefully we get home before midnight.
Yeah. But we should be home by, if we don't lollygag, because we don't have anything to like turn in for rental cars or anything, should be on the road by 6:30.
So yeah, it'll be like right at midnight.
Or 11.
It's like 4.5 hours and we'll probably make at least one stop. We have to stop right away. The car's like
Oh, yeah.
running on fumes.
Megan's listening. I told her that the stream was live, said she could eavesdrop. Hi, Megan. Not a garbage in here. So tonight after dinner, go home, or go back to the hotel and get ready for going home. Is there anything else you wanted to do before we left?
Not really.
Well, I did go back here next year, and I told Mark we could had a couple of days on either side to go visit Huntington.
Canada.
We can't, we gotta make sure stuff has its passport.
Having a couple of days is always like hard though, because animals and stuff.
Yeah, the nice thing about this conference is it's over the weekend, so it doesn't really, like, the actual conference doesn't impact me or anything. The animals, yes.
Adventure easy.
Oh my gosh, if she would be able to travel, she would hate it. They seem to be doing fine. I checked in on them this morning.
It's only for
Megan says we can't take more time too because she's also impacted. You need to be
probably. It's close enough now. It's within 5 minutes.
ready.
Thanks.
Also, don't feel bad if you don't have high attendance. Lightning talks are happening right now as well, and it's the end of the day too.
Yeah. What?
The door stops and stuff. Do you want me to try to help?
I was afraid of you.
Like when we call IT to come fix a problem and it starts working.
Yeah. This talk is being recorded for quality assurance.
We're going to start a little bit early here today by about a minute. Good morning, or good afternoon, everybody. Welcome to our second day of Linux Fest. Today we'll be presenting Better Together using observability tools and for STEM and analytics by Tice. Enjoy.
Hey everyone, my name is Matthias Palmersheim. Today I'm going to be talking to you about using your observability as a SIM, your observability tools for a SIM as well. A bit about me, I'm an observability enthusiast. I'm so obsessed with it that on the first date with my wife, I would not shut up about centralized logging. I don't know why she's still with me, but along with my day job at Victoria Metrics, I have a side project called Shiftmon where I take all of the awesome tools that we make at Victoria Metrics and glue them all together so you kind of have like an observability tool in a single box. At Victoria Metrics, I'm a solutions engineer where I help our enterprise customers and community members get the most out of our observability tools. I'm also a huge fan of animals. I have 5 of them at home, our cats in the slide here, and I also enjoy memes, which is going to be very obvious in this talk. If you want to contact me, my work email is at the bottom of the slide, and I also have a links website, links.shiftsystems.net, that is like Matrix, LinkedIn, pretty much any way you can get a hold of me. A couple of definitions I want to establish before we get into the meat of the talk. One of them is what is observability, and the definition I like to use is that it's gathering telemetry to interrogate systems. A lot of people will use the definition of its metrics, logs, and traces, which is like saying a cake is flour, eggs, and milk. Those are common ingredients, but you don't necessarily have to have them all, or you might have more ingredients, and it doesn't capture the fact that it's a process of gluing them all together to make observability work. It focuses on notifying you when things aren't working, so like getting an alert when a service is unavailable or is not performing as expected. It's supposed to help with proactive troubleshooting, so you can do things like troubleshoot when one instance of the service behind a load balancer is down rather than getting notified when the entire load balancer has failed or everything behind it has failed. It can also help you correlate data from multiple sources so you can see the logs and the resource usage on a node at any given time. And it uses abstractions like data visualization tools and database queries to make it more useful. And then what's a SIM? SIM is an acronym for Security, Information, and Event Management. And it's similar to observability. You're gathering telemetry from a bunch of different sources, and instead of alerting on irregularities with like performance of an application or if an application is unavailable, it's more about like irregular access or somebody attempting to break into an application or an indication that something has broken into an application. It's correlating data from multiple sources, so like from a cloud provider and the individual VMs in that cloud provider, like collecting logs from a SaaS service, and it uses similar abstractions to observability to make sense of massive amounts of data. One other thing they share in common is the incidents are extremely similar. So I've been on Sev1 outages for both like companies I've worked for and for our customers, and I've also gotten waken up at like, or not waken up, I also had an incident where it was supposed to be my PTO for Christmas. I was about to relive my childhood, sit down with a bowl of Crunch Berries and watch Rocco's Modern Life. And all of a sudden I get a call from my manager saying, hey, one of our bank websites was compromised. I need you to get on and start fixing this. And I like wasn't able to even eat breakfast until they were already until my cereal was soggy. So like if you say soggy Crunch Berries in front of me, I'm gonna shudder every time. And the incidents I've had for like work for database outages are extremely similar to where everyone's like getting called in. You have a bunch of people blowing up Slacker teams, and it's just not fun. So that's another area where these two things are very similar. So these tools are using similar abstractions. The stress is very similar. The incidents also have very similar negative effects for the business. So like one thing with incidents is that like you have financial loss, you can have compliance issues where like you promise your customers the service will be available a certain amount of time, and you can cause financial loss that way. For the security use case, you're also going to notice that you can lose money due to compliance failures. So like HIPAA fines per record that is compromised, and that's another instance where the incidents are extremely similar. There's also a bunch of issues with having these two things be separate. So the first one is going to be agent fatigue, which is a term that I use to describe where you have separate agents for security and for observability. And what that could look like is you have one agent that's collecting logs and forwarding them off to a SIEM, and another one that's going to the observability system. These agents end up like Jaime Lannister trying to keep track of which O's he has to keep. And it gets extremely confusing, and they could even conflict with each other because the security agent could need to read logs from var log, and it would need conflicting permissions with the observability agent that's also needing to collect logs out of var log. They can cause issues with antivirus as well. So like usually observability agents need to have high levels of permission, and so do security agents, and they can kind of step on each other's toes.
Are you using agent in the sense of like an LLM?
No, thank you. I forgot that word got overloaded since the last time I gave this talk. So by agent, I mean something like Telegraph or like your EDR endpoint software, where it is a program running on the machine to collect telemetry. Yeah.
Okay.
Yeah. Thank you so much for that. I forgot the term agent means.
It's been destroyed.
So good call out there. It's also a great place to place blame. So something I've noticed rolling out observability at big companies is people will be lazy and just be like, well, it's all the security agents and all the observability tools we have to put in, and that's why our application uses so many resources. And so if you have multiple agents, it can turn into multiple excuses for application owners to blame like slow performance. Another problem too is it can lead to duplication of effort. So storing, especially in like public clouds, the most expensive thing you can do, the two most expensive things that you do are egress and storing data long term. And that's essentially what observability is you're egressing data out of a network and then storing it somewhere else. And so if you're like collecting access logs from an application so you can monitor error rates and then forwarding those off to a different system to see if there's any irregularities with like which endpoints are getting hit, you're storing those logs twice, which can become extremely expensive. It can also be another place where things can get compromised because now you have to worry about securing the monitoring or the observability tool. And you also have to deal with securing and managing tools as well. Securing the SIM as well. Another problem this can cause is context switching during incidents. So a lot of times incidents don't usually respect like your organizational boundaries. And so if you do have a security issue, it's likely also impacting production, and you're having to have the SIM tool open and the observability tool open. And usually when you have incidents, you're in like the soggy crunchberry state of mind where like you weren't expecting to be working on December 23rd. You were expecting to be being lazy during the holidays. And it can be really challenging when you're having to remember like multiple different query languages, how different dashboards work. You're really tired because it's not like they don't wait for 2 p.m. when you don't have meetings. They always happen at the most inconvenient time. And that on top of having to switch back and forth between like the security dashboards and the observability dashboards is tricky. Another thing too is if it's your first time being roped into one or the other type of incident, you can end up with access issues where you don't have the ability to see things in a certain tool, and you're figuring this out when time's at a premium because incidents can be extremely expensive into like the thousands or tens of $1,000s per hour or even per minute in some extreme cases. Another problem too is you end up with different teams seeing different parts of the problem, but they don't see the whole problem. So like sims are very log centric. So if they see that, hey, we're now collecting all the data we need for compliance, but the agent is using a ton of resources on the box, they don't see that like they're impacting production performance. And the more common thing that happens is like developers in the observability tool are going to see that, oh, hey, my application is working, and they're going to ignore the security scan results that live in the sim tool. And it can lead to like people conflating insecure things to being working things, which really shouldn't be the case. So if there's all these problems with these tools living in separate places and having separate workflows, why don't we just combine the two? Biggest one is the tools have kind of like evolved differently. So they have different functionalities and different needs, and they're both very big and complex problems. So it's extremely challenging to like find something that meets everyone's needs. So kind of the way sim tools matured was that they were essentially centralized logging, and then they figured out how to scale and meet those needs and answer the types of questions security analysts would want to ask. And then observability tooling, if you go back before we were using things like distributed databases to do it, we were using tools that just did like pass-fail checks like Zabbix or Nagios, and they weren't really fit for answering questions like, hey, how many people tried to access this application, or was this endpoint hit? And so until fairly recently, like there weren't a lot of tools that can meet both teams' needs, and it can be very hard to fit everyone's needs into one tool. Also, migrations suck in general, whether it's observability or like anything else. So you have to go shopping for a bunch of different solutions. You have to send vendor questionnaires out, and those can take forever to fill. You also have to replicate both teams' workflows. And so even just doing like an observability tool migration, you almost have to learn the entire business just for that, because you have to understand how those users are monitoring their applications and figure out how they're using the existing tool to make sure you can port all of those workloads over to another tool. And a lot of times you're the new guy and nobody trusts the new guy right away. So it can take time to build those trust and relationships in order for them to trust you to migrate over as well. And then phasing out the old system can be extremely challenging as well. Like you think you have everything in the new system, all your tests and like all the audits you've done to make sure everything's migrated over, but you're still paranoid that there's like the one box sitting in the corner that's just humming along and nobody's going to notice until you turn off the old system. Another issue too is communicating values. So like a lot of times people will view having separate SIM and observability tools as like a working state and everything's fine. And a lot of the benefits aren't things that like directly impact the bottom line. And a lot of the things are going to be communicated from an engineer's perspective and not necessarily your boss's perspective. So like engineers are going to be worried about reliability, ease of use, and things that make their life easier. And they might not communicate it in terms of like return on investment, or we're going to save this much money only storing the logs once instead of twice. And so that communication breakdown can also make migrations take longer or even get delayed entirely, just because it's really hard to speak in terms of a manager if you're an engineer, or if you're a manager, it can be a bit challenging to understand why your engineer is focused on things that make their life easier but not make the company more money. One trick, a few tricks that I used to help with that is highlighting profit potential. So like putting dollar signs onto things. So again, if you're storing logs twice, once for observability and then another time for security use cases, you can say like, hey, we can like cut the amount of logs we have to store in object storage or on block storage in half, and that can be a huge cost savings. Mentioning outages can be a big deal. So if you can demonstrate that having security and observability in one place reduces mean time to resolution and those sorts of metrics, you can communicate that like, hey, that outage that cost us a ton of money last year would have been shorter if we had all the information in one place. Also, you can mention that better observability helps prevent those outages in the first place. So you can say that, hey, now that we have better observability, we can be proactive and notice when one node behind a load balancer is down before the whole application is down. That can be incredibly useful. Also, when you are putting costs to things, yes, cloud bills are expensive, but humans are even more expensive in most cases. So focusing on like the amount of people you need to manage both systems and the amount of toil that it takes to manage both systems can usually outstrip the amount of money or outpace the amount of money you are saving on cloud bills. So we've kind of talked about like why they're not good apart and how we can help our leadership or convince our leadership to have observability tools and SIMs be the same thing. So here's some benefits of merging the two systems. One is you get unified tools for management. So one big thing that a lot of decision makers like is that they can view all of their data in one dashboard. So they don't have to go to a separate tool or look at multiple different reports to see that the environment is secure and we're meeting our security goals and our availability goals. They can view this in one place. You can have one team that's responsible for onboarding tools. So again, because there's so much overlap in the type of data we're collecting, the security team can kind of just ask the SRE team to like grab a couple of other log files or add a couple of other plugins to their existing observability tool. And then the SRE team's responsible for instrumentation, and now the security team doesn't have to chase everyone down as well. You don't have any of that friction between tools because you just have the observability agents collecting all this information yourself. It gives people one less place to blame agents, and you're only sending and storing that data once, which is going to be easier to secure and cheaper to store. You also have people that are having an easier time during incidents because they only have to have the security tool or the observability tool open. They don't have to have different dashboards for different types of data open. There's a unified source of truth. So the security team and the operations team or the development team are reading off the same data and they have the same view of the world. You don't have any of those weird access issues where you have an ops person hopping on a security incident and they don't have access to any of the tools and they're sitting on their hands waiting to get access during an incident where time is at a premium. Operations can also receive security alerts. So if there are any like outdated packages or any of those sorts of things, you can have the operations team get notified of that in like a steady stream rather than when like audit time comes around, they get influx of tickets in order to fix things. And then security can also check if they're impacting reliability or any of the observability metrics because the same place where they are viewing their security data, they also have the reliability metrics and they can have access to those as well. It's not all sunshine and roses though. One of the benefits of having dedicated tools for different jobs is that they have a lot of out-of-the-box integrations. So because it's a relatively new thing to treat observability and a SIM as a single tool, there's a lot of really good integrations for SIM tools that don't necessarily map one-to-one into observability tools. Particularly, this is challenging with SaaS integrations. So like Google Workspace, M365, or other software as a service tools, they will have a lot of SIM integrations, but a lot of those SIM integrations are for specific SIM tools and they're not like giving you an open telemetry endpoint to send all your data to. That's getting better, but it's still not great. And that can lead to like an inconsistent experience, or it can raise the challenge, or it can make migrating off of your existing SIM tool a bit harder. Also, there's a bunch of knowledge hidden all throughout your security tool. So when you do migrate, you have to make sure that the knowledge hidden inside of dashboards and alert rules and those sorts of things get migrated. And you have to make sure that all those workflows stay supported, all the data enrichment from ingestion and all that information can kind of make it over. Another thing that's hidden, or like knowledge you don't think about that's really important that a lot of SIM tools provide you is like CVE feeds or like MITRE information. A lot of observability vendors don't have that embedded in their tools to the same degree that SIM tools do. Another issue you might have is if you're using like a SaaS or a cloud vendor, they might be picky about the type of data you send to them. So if you're using a managed service, they might not support like the number of fields or the volume of data you need to send both data to both places. And a lot of times, especially if you're using a SaaS tool, they might not support the level of customization it takes to put the security dashboards and workflows inside of their tool. And that kind of stinks because, like, yes, you can self-host a lot of the cloud solutions, but the benefit of using a cloud solution is that, like, it's someone else's ops team that's responsible for scaling and carrying and feeding for that service. And if you do have to go to a self-hosted thing, that is now your team's burden. Another thing too is you have to get buy-in from a wider group of people in order to perform migrations or make changes. So before, when they were separate tools, it was just the security team that had to agree on like upgrade paths or maintenance windows or those sorts of things. But now you're having to deal with getting buy-in from the operations team as well. So the way I've tried to make a lot of these downsides easier is I maintain a project called ShiftMon, which is taking Victoria Metrics, Victoria Logs, Grafana, Alert Manager, and Telegraph, gluing it all together with Ansible, and it gives you one place where you can send all of your observability data and most of your security data into one place. There's a link to the GitLab project there. And this supports a ton of different inputs for logs and metrics and things that security professionals would be interested in. So it can work as a syslog server. It can collect logs from Microsoft Defender. Pretty much every open source web server and IIS as well for collecting logs and metrics. It works with Suricata and CrowdSec for intrusion prevention and detection. It supports free IPA for identity management, and it also supports Authentic. And if you are using Windows to collect individual events, it also works with Sysmon. There's some basic support for Tetragon and I believe Falco, but it could definitely use some more work, and it's on my roadmap to improve that. There's also a lot of migrations that, even though they're not in ShiftMon today, they would be fairly easy to integrate. So you could, I checked SentinelOne and CrowdStrike. They both have tools that will let you just send a syslog feed off to an endpoint. So as long as your ShiftMon instance or your Victoria Logs instance would be accessible to those vendors, you would be able to forward that over syslog. Most firewall solutions have SNMP or allow you to install Telegraph or just let you forward raw syslog off. Self-hosted applications, there's only a finite amount of ways they can generate logs and metrics, and ShiftMon and the Victoria stack kind of make that fairly easy to integrate. So collecting logs from Docker containers just works out of the box in ShiftMon. You can give it an arbitrary list of files to tail, or you can just forward everything through syslog. One thing I don't daily drive, so I don't feel comfortable creating like an opinionated setup for, is Active Directory or Entra ID. And that's just because I don't use those tools day to day. So having like my opinions of them packaged up and shipped off to users doesn't seem like a great idea. Some integrations that are definitely possible, but a bit more challenging due to some reasons I kind of talked about earlier, would be like Google Workspace or Entra ID, because those cloud tools require you to like interact with the public clouds made by those vendors. You kind of have to run it through their observability tool and then export it off to your observability tool. And that's also the case for a lot of managed services in like GCP, Azure, and AWS, where they don't let you directly take the output from like Google Cloud Run or a managed database in any of them and pipe it directly through OTel. You're usually having to pipe that through their observability solution first. And then with software as a service products, a lot of times they don't give you like an API for metrics. They expect to either push it to you or just don't have anything at all. And so those migrations are somewhere between a painful ordeal and impossible. Also, I'm not the only person that thinks that observability and security are very similar, and we can use similar tools to get run both of them at once. NVIDIA gave a talk about using Grafana Loki as a SIEM a couple of years ago at GrafanaCon. There's also a cool new project I want to play with called SIEM in a Box, where they will let you run either Prometheus and Loki or Victoria metrics and Victoria logs with Falco to get endpoint metrics and security logs in one place. And for commercial products, there's also Datadog and Elastic offer both of those as one product of one build. There's also some use cases that I have for this product that I wanted to go through quick. So one of them is host compliance. I use Ansible, but I use it backwards. So Ansible is normally like you SSH into the host and have it perform automations for you. But you can also run Ansible in a pull fashion where it downloads code from Git or an HTTP endpoint, and then it will run Ansible locally. And that's how I make sure all my hosts are staying up to date. They have the latest security patches and settings and compliance. And because it's just running as a systemd unit, I can have Telegraph monitor, hey, is this systemd unit, is it in a failed state? And if it is in a failed state for a certain time, I get a notification on my phone, and I can go through and look at the metrics, notice that that service is in a failed state. And then I could also look at the logs inside of the same dashboard in order to see that, oh, this is the task that the automation failed on. So I'm not getting a notification that says, this thing's broken, good luck, have fun. I get linked directly to a dashboard that gives me the information that the service has failed, when it failed, and what happened around that failure. Another thing that's really nice with Shiftmon is you can investigate what happens after a user clicks a spicy link. So most common form of compromise is users on a device, they click a link from a phishing email, and then that link downloads and executes malware. And Shiftmon, because it supports tools like Tetragon and Sysmon, you can collect all of those events and see like what DNS queries were being made, what new registry entries are being created, and what things are being executed on Windows. This also works on Linux in a similar fashion for like AuditD, or if you're using Tetragon or Falco, you can also forward those logs to Shiftmon as well. Again, we can aggregate things by which executables are doing which things, down to like DNS queries or tweaking registry entries as well. Another thing that's really cool is we can look at firewall metrics as well. So security people aren't just seeing things like net flow from the individual logs. They can aggregate those over time into metrics as well. And I think I do have a functioning live demo for this. So here I can see the metrics on my router. I can see it's not having any issues with resource exhaustion, but now I can go down here, see how much bandwidth is going through. So I can load how much bandwidth is going through the firewall over 90 days very quickly because it's being stored as a relatively cheap metric. And I can see when there's spikes of bandwidth happening, which could be an indicator of compromise, without having to do something like aggregate all the flows from all the logs together. I can use cheap metrics to do this rather than having to aggregate months worth of logs. But if we did want to see individual flows, we can go down here and we can go through the NF table rules as well, which IP addresses are being accessed, which type of traffic is being accessed, and even individual firewall rules and flows as well. Another nice thing too is because the security team is able to see availability information, we can go through and look through black box monitoring checks as well. So black box monitoring is the process of simulating accessing a system as if you're a user. So rather than just relying on like a health check from a load balancer to see if an application is up, we're simulating an external tool poking the endpoint to see if it's available or not. So here we can see like response times over an extended period of time. So if there was a security scan or some other pen test that could have been impacting availability, the security team can prove their innocence. So rather than just getting blamed by the ops team of like, there was an outage the same time as a pen test, this is totally your fault, they can prove that they weren't submitting an abnormal amount of traffic or impacting availability. And the security team can kind of prove their innocence without having to answer to like cranky sysadmins. I say that lovingly as a cranky sysadmin. Another cool thing as well, this is the only part of the talk that isn't available in open source, but this is using VM Anomaly, which is our anomaly detection solution. We can also see if there were anomalies going through the product at that time as well. So I can pick on an individual service and see that during this time there was an anomalous response time. And then I would be able to go back through ShiftMon, go through the logs for that service, and see what was happening during that time. Prior to giving this talk, this was actually the first time I received a good amount of value out of having distributed tracing. So open tracing is basically like following a request all the way through the application. So even like my matrix server requires hopping through a load balancer that goes from the outside of my network to inside my network, and then another load balancer to route requests to the right part of the Synapse application. And then it goes through the Synapse application through a database. So that very long multi-step process just to self-host my matrix server, it can be useful to see where the individual trace is going. And I was struggling to see if the traces were being sent back over the network. I was struggling to see like whether or not traces were getting out of my DMZ into my into ShiftMon. And it was really cool that I could just go through and look through the Suricata logs to see if that event was getting blocked or getting through. And I never had that experience before where I was able to like look at the security data from the intrusion detection system in front of my router to see if observability data was being blocked. So it's really cool being both the security person and the sysadmin at the same time, being able to look at those tools to see if they were working together or not. Slides should be linked and publicly available, but those are all the external resources. And I have time for questions. Cool. Any questions, comments?
How do you feel like the security industry is being like affected by the current shifts and everything? I'm a software engineer for 20 years now. I was thinking of doing more in security end because I don't know what's happening to the software industry in general. So do you think the security end is getting hammered as bad with all these different SIM tools? Like when I was trying to do hack in the box and whatnot, I noticed there was 1,000 tools for everything. But what's stopping a company from coming in and just making one tool that's going to replace them all now? And I don't know, what is the future of in general?
I'm seeing most observability data moving towards open telemetry, which it's nice that everybody's starting to agree on a standard. There's issues with the standard that's a talk in itself. But I'm guessing that because the amount of data we need to store is getting obscene and people are becoming really cost sensitive now, that we're going to see more people treat their observability the SIM is basically going to be a plug into their observability rather than having them be isolated things, because logging 100 terabytes a day twice sounds awful.
Could you please go back to the previous slide?
Yes. In the back.
Is there a usefulness or utility to be able to run this in smaller environments than enterprise scale?
Yes.
Or would this be something that would be too heavy for one person to run on a whole lab?
So everything I showed you as example is running inside of my house right now on a 2 CPU, 4 gig of RAM virtual machine. So just to prove that out. So yes, it is useful. That OTel example was extremely helpful, because being able to see where the trace was starting to fail to propagate, I was able to prove the network innocence. And that's another common pattern is oh, it's the network's fault, and you go down a long rabbit hole. But if you're able to see that no, the packet got through, it's the OTel config was broken in that case. So if I go down to Armin, memory usage is a bit high, but that's the ShiftMon box that I have in my house, and it's running 2 CPUs and 4 gigs of RAM. And just to get the scale of logs I'm processing, because I'm intentionally trying to like juice those numbers, or to like bump those numbers up. I'm ingesting 200 gigs of logs a day, and it's total. Sorry, I'm ingesting like 8 gigs of logs a day, and it's compressing like 27-1. That's high end of reasonable. Worst thing I've seen in the real world is like 8-1. When we do like capacity estimates, we assume it'll compress 10-1.
I get 35x and I have 15 gigs of logs per day.
Yeah. And you're using Kubernetes, which is a bit more stressful than normal Linux logging because distributed system stuff.
Yep, and pods being recreated all the time.
Yeah. Great question. Anyone else? Cool. I'll be around at the Victoria Metrics booth till the end of the day. If anyone wants to chat about this at all.
His contact information, you can reach out to him for those as well if you want.
Okay.
Yeah. I know I had made them clickable links instead of the URLs because usually we share the slides out when he presents, but I realized that.
It'll be online as well.
Yes. But we should, when the videos come out for the conference, like the individual ones, we should tag like or attach a link to our slide deck.
Yeah, if you reach out to me and just ask like, hey, can you share this with me all?
Okay.
Yeah.
Megan said she was clapping from the remote viewing section.
She didn't see the last one.
Yeah.
Probably retiring.
I don't know where that
In here. Oh, it's in the corner.
Thank you.
John, thank you. My camera away.
No problem.
Not that it's a bad talk, but it is definitely, I think it's over some people's heads. Probably.
Yeah, I'm retiring.
Yeah,
it's fine.
He's got more entertaining content now that he's been doing with it.
Yeah.
The one he gave yesterday was really good. Minus
No,
the
it was.
slides.
And I want to do the Home Assistant one too, where I talk about like.
That one I think should be a.
That'll be a good one.
You mean?
Yeah.
Yeah.
That one could almost be 2 separate ones you do.
Like have 2 versions or.
Like a part 1 and a part 2 almost. There's
That's
enough
what makes you
content
talk
there.
fast.
Well, he can talk fast. He didn't breathe like that entire time. I don't know if you noticed.
I got used to. I think I ruined myself on that talk just because like I tried to squish it into a 5-minute long like talk once.
If anybody's interested, they're doing 20% off solo keys. And that's including the new ones.
I'm happy enough with my keys.
I need new solo keys because the ones I have active exploits against some of those and they're old enough that they're not getting CLI support anymore. Not that I use it for anything more than Fido, but it's time for new keys. And the biggest thing for me has been cost because 2 new solo keys is $100. So the 20% off plus free shipping. And well, you know, you need 2 of them at least.
I know, because mine one broke when I was in Wisconsin in the middle of nowhere. Thankfully, that.
Oh, your UV key?
Yeah.
Yep.
My solo key broke.
Solo key. Sorry.
And the new ones are cool. The ones that I got are USB-C and NFC. Okay. I got this super cheap USB with around the dash and the amount of
Yes, ma'am. Hi. I'm Kara. I'll be your room captain today.
Thanks. How's your day going?
Again?
How's your day going?
Not too bad. How about yours?
Oh, pretty well.
That is a CMI.
Good for yourself.
Over here somewhere. Yeah.
That does not look like Wisconsin.
There we are.
So I will introduce you at the time. I'll close the door, introduce you, and we've got 30 minutes for you to talk, 15 minutes for questions. I'm just gonna let you keep going until you start getting too close to the next time, and then I'll be like, hey, wrap it up.
All right. Do you mind if I run to the restroom?
Yep, go ahead. Of course. One real quick question. Are you using ceramic blood or?
Do you need me? I mean, I kind of tend to, but I can try to stay in one spot if you need me to.
I think it's fine. It's whatever you want to do. I can just move the camera back or higher or whatever. It's
I mean, if I can move from like here to here.
Yeah. Okay. Give me 1 second. Is the space as requested?
Perfect. Nope, that is not.
Just keeps turning over. I could flip the whole thing, but still do it. I've got my own real strong opinion, but everyone sees overlap. Yeah, every subject, but mainly self-hosting, open source, but I'm also creating a new platform pretty soon. So I have web design on my list. Let's see if it matches. Oh yeah, yeah. Big overlap.
experience systems operating. I've never been to an operating system before or after. Well, it'll be everything. It is super superficial. Like, imagine an insufficient static web server, but it can also serve dynamic pages just as fast. Super secure, OLM protocol, HTTPS, it's not really running on the server. But it can do everything. Messages, downloads, streaming. So, I have a really tight design that's universally compatible. My own system, so the only thing on the front side of the server is the HTML file. And then the back side is my own proprietary development. There's nothing else back there. So the entire server is just HTTP, and that's it, and security. That's it. Super simple, but solves a lot of problems. Everything. So I've PC that so people will get a free homepage. It's free. That's key. It's tamper-proof, so the network level will not drop your messages strategically. All kinds of other things that we're doing.
Good afternoon, everybody. Welcome to Linux Fest. Hope you guys have been enjoying your time today. I'm presenting to you Alex Moon with the request tax reevaluating 20 years of web performance dogma. Please enjoy.
Thanks, Kira. Hi, everyone. I guess I need to put my phone on silent. But other than that, welcome. So, as she said, I'm Alex. I've done some things in my life. I used to be a sysadmin. That's how I kind of got started. Been a web developer for somewhere around 10 years, depending on how you count. I work at WP Engine. We do WordPress stuff, if anyone... So we're going to get into some statistics and some tests I've run. From my background, you might notice that there's nothing about mathematician, statistician, network engineer. I'm a guy who builds websites who might know something, but might not also. So a lot of what you're going to see is kind of like my experience and what I've learned about building things that are more performant at scale, and kind of a layman's look at really HTTP3 and how that's changed the game for a lot of what we do when building websites. Anomalies may exist in the data, right? I ran this on my own laptop while doing other projects, so if something looks weird, it's probably because I decided to do something in the background. But I think at the end of the day, we'll still learn some things. If you guys have any questions on kind of what's there, I will have a repo at the end for all this code. But this is kind of the larger overview of the setup I use for testing. So why am I talking? Before we get into that, 2 phases, right? So phase 1 data we'll get into here was really just testing HTTP1 versus HTTP3. I use Caddy as a web server, which is written in Go. And that's just testing overhead of HTTP1 versus HTTP3. And in the second phase, we get into cache and validation changes, and we'll look at that. And that actually does have a backend. Come on in. And that is just the node server I mentioned earlier, serving that. So, why did I decide to give this talk? Really, it happened early January. I got back from Christmas and holidays. And first thing one of my coworkers does is send me a link to this new GraphQL client library. And I'm looking through it like, okay, another GraphQL client library. What's special about this? And on the homepage, they had a couple kind of bullet points that they're really proud of. And one of them was GraphQL client batching. Anyone familiar with GraphQL or what client batching is? One person, all right. For those that don't know, GraphQL, right, you tell it what you want. So because of that, and it's all a connected graph, you could make one really massive request for anything possible you want out of your data systems, or you can make a bunch of little small requests. And what batching does is it says, hey, if you make multiple small requests within some time frame, some window, we'll just merge those into one giant request and make one big request to you. And the argument for that is less round trips to the server. And they were really proud of this feature, obviously. It was kind of a key piece of this client. And I had two simultaneous reactions, or nearly simultaneous reactions. One part of my brain went, that's really great. Network round trips are terrible. And then I stopped and went, wait a minute. I've been working for WP Engine for 2 years at this point, 3 years. And over the couple years of serving our customers and working with our headless customers who are doing headless WordPress, we'd learned one really important thing. And that was batching GraphQL requests was like the worst thing you could possibly do for performance. We were never automating that, but like some of the early tools we'd built had assumed like one giant GraphQL request per route. What that might look like, let's take like a basic blog post as an example, is you've got a navigation menu on there, you've got what's in author bio, and then you actually have like the content of your page or your post. And if you have 100 posts by that same author and just one piece of blog content changes, you have to, your server is going to have to go fetch that new request, and it's going to, from the database, pull all that nav information, right? It's going to pull all that, the blog post, and it's going to pull whatever author bio information. And it's going to regenerate that page. Not a big deal. But if the author decides to change their Twitter profile, update their name, whatever it is, change anything about their author bio, you're going to have to remake that same data request across 100 posts. And on the back end, the GraphQL is fetching for each one of those posts because it's a unique request based on the per route data for nav, for author, for post data. Now, if you break that same GraphQL request into 3 pieces, right, you don't bundle the request effectively. You now get one server request for that author bio on your first page you're regenerating. It updates the cache, and now everything is cached. All 3 different requests are cached across your next 100 regenerations of pages. So you still got to regenerate the HTML either way, but now your data load on your backend is much lower. And that's exactly what we were saying, right? People who weren't effectively breaking out their GraphQL requests were just destroying their backends. And to help them, we were encouraging people to, hey, make more granular GraphQL requests. And this idea, right, my context and where I came to this is from GraphQL, but this applies to REST, this applies to HTTP bundling, JavaScript bundling, CSS bundling, right? The larger our bundles, the less we can effectively cache them. So why do we bundle, right? Well, let's get in our Wayback Machine and look at HTTP and where we came from. And ultimately, HTTP1 and TCP, because that's what HTTP uses, punishes doing small requests, right? We had head-of-line blocking, so HTTP didn't fundamentally understand making multiple parallel requests, and thus we got one connection to an origin, and at that origin we would serially request one file at a time. And because of this, if we got like a large image file, even though we have like a little 1 kilobyte CSS file over here that we really want, our image file is breaking it, right? So order of getting stuff ordered right and when it got downloaded was really important. And browsers helped us with this, right? They started parallelizing TCP. They gave us 6 parallel connections per request. They limited it at 6 because they didn't want you to self-DDoS your own server. We also, as developers before this especially, we did things like domain sharding. Anyone remember having to domain shard? This was basically like css.mydomain.com and js.mydomain.com, and they all ended at the same server. But by splitting up the domain, you trick the browser into opening parallel connections, right? We did, oh gosh, I'm blanking on the word, multiple images in one file, right? So you'd have like 5 icons or versions of an icon in one file. And then you would sit and use absolute positioning to determine which icon the user would actually see. And this was a form of bundling, right? And obviously we had actual bundlers for CSF and JavaScript, and we inline things, right? So there was all ways to work around this, but ultimately, we are still limited in how well we could parallels. We had header overhead, right? Whether it's cookies or other headers, every single one of those HTTP requests required those overheads. And at large file sizes, a half a kilobyte of headers didn't really matter. But if you're requesting a half a kilobyte of data over a single HTTP connection, you could easily double the size of your request just from headers alone. And then we get into TCP, right? We had a round trip and a handshake for TCP, and then another one for TLS, right? That's why people that are really worried about performance didn't implement TLS. It's crazy to think about in this world, but even 15 years ago, that wasn't unheard of. And then finally, TCP slow start. Basically, TCP doesn't magically know how fast your internet bandwidth is, and all of the pipes in between you and the server, and so it slowly ramps up how fast it downloads a file. Well, what this meant was that really small files they would download before that ramp up happened, right? So a large file would use your entire bandwidth, but a small file might only use a third, a half of your bandwidth. Thus, once again, HTTP told us, we've got a bundle, right? Everything of how TCP and HTTP1 worked was bundle. So this is our first chart of data. Quick refresh. We'll almost always fix those layouts. But basically what we're seeing here, right, is bottom left is single bundle. And obviously the larger the bundle, the longer it takes to download. And as we move to the right, as we split that same total payload into smaller chunks, the download time increases, right? Interestingly, right, when the bundles are large enough here, it stays a little flatter, right? We do get a benefit from that 6 parallel requests, but it's ultimately never enough to fully mitigate the fact that we still are making multiple requests, right? Ultimately, one bundle is still faster than 10. This slope is just a little less steep than this slope is when we're doing really small bundles. So that's that punishment we're seeing on HTTP1. So where do we go from there? What about caching, right? How does this affect caching? A single change line invalidates a whole bundle. Right? You're potentially re-downloading kilobytes or bytes of data for little bits of change. Your cache hit rate drops, this means, and in the world of caching, cache hit rates are everything, right? We want those as high as possible. So because of this, like, we had this tension between caching says we should have smaller pieces that are more highly cacheable to increase our cache hit rate, but our overall network overhead means we actually want fewer bundles, which hurts our caching, and it was this weird balance, right? And so at least in JavaScript land, where I spend a lot of time, right, we started heavily doing code splitting. The default in JavaScript world is like you have your framework bundle, so like if you're doing a React application, you would have React and React DOM in a bundle. You would have your basic application code in another bundle, and then like your per route code would be in a third bundle. And those would be like your 3 basic JavaScript bundles and like your average React app. And this was pretty well adopted across frameworks and other systems. And this was seen as a balance, right? Like you could update React and not, if you didn't update your application code, it wouldn't invalidate all those bundles, and vice versa, right? React would be heavily cached, but as you update your app, that will get purged and changed. So this was seen as like a balancing act. But once again, it was ultimately a balancing act between TCP and HTTP1 performance gains and caching-based performance gains. So can we fix this, right? Can we resolve this tension and get HTTP3 or HTTP and caching to agree so that doing what's good for caching is also doing what's good for HTTP? Well, Google and a lot of other smart people got together and they invented HTTP2. which was known internally as Speedy. It's pretty rare you see references to Speedy, but if like you get into the internals of like Firefox and logs, sometimes you still see Speedy references. It's just HTTP2. Right, so we got multiplexing, aka parallel requests, and these were done via frames. That term will come up a couple times, so that's all you need to know about it. Is frames is how we thought about downloading multiple frames, and this was right at the HTTP level. And we got header compression, which hugely reduced that overhead, and we're now doing a single request per origin. Right, so no longer are we doing 18 round trips to establish our 6 parallel connections. We're doing 2 to 3. Right, we still got one for TCP, we still got one for TLS, but then HTTP is now just doing all of its parallelization inside at the application level. Unfortunately, despite parallel requests, we actually still have header-line blocking. The difference is this header-line blocking has moved from the document level, right, where a large image was blocking a bunch of other little small downloads, to the packet level. Because TCP doesn't understand what's happening inside of HTTP, it gets, TCP loses a packet, it stops all those frames doing all that parallelization and makes them wait for that one packet to come across, and then it does the slow start resumption, right? We still got that TCP slow start that's limiting our potential bandwidth usage. And we still have that TLS handshake latency, right? So it is what it is, but HTTP2 was a huge performance win, right? It was still not win. Unfortunately, there were still some issues that we had to work through. So once again, Google and friends got together and they said, let's fix this. And somewhere in the process, they had originally named HTTP3 Quick, like HTTP2 was Speedy. Smart people realized that Quick's really cool. I can't get into it too much. I have limited amounts of time, unfortunately. But if you want to know more about Quick, come talk to me afterwards. But basically, we like leveraged just raw UDP packets instead of using TCP to get around this, and we moved Quick into user space and out of the kernel so we could iterate on it faster. So HTTP3 is now done over Quick, which means we could also do things like DNS over Quick and whatever other favorite protocol over Quick. So Quick will expand eventually beyond HTTP3, though it's mostly used there at this point in time. So what did this get us? We still have multiplexing, though this is done, I believe, more like headers and body are done in different frames. The actual parallel document fetching is done at the Quick level. We have header compression. It's now QPAC because it's for Quick instead of TCP. We still have a single connection per origin. But we've now eliminated TCP, right? So we have no more TCP head-of-line blocking. We have independent streams. You drop a packet, only that single stream is affected, not all the streams and all your files, right? We've now eliminated slow start penalty. We now have what's referred to as 0 round-trip resumptions. This could be either packet loss, or it could be overall, like, you haven't been to the server in a week and you're revisiting it. And because there's like a relationship here, your connection can reestablish at higher rates faster than it could have with TCP slow start. And finally, we've built TLS into Quick, right? So there's no TCP then TLS, there's no Quick then TLS. TLS and Quick are all one round trip, right? So we've eliminated a further overhead via round trips. And finally, I'll mention connection migration. This has nothing to do with this talk. I just think it's a really cool feature of Quick. And that is because TCP works on IP addresses and ports on both client and server. If you jump from mobile device connection to Wi-Fi, everything stops, right? Your Zoom call freezes as you leave the house. It sits and tries to figure it out. The servers have to reconnect, and then bits start flowing again. That gets eliminated with Quick. It does it on like an connection ID effectively, and so as soon as those bits start flowing from a new address, it just fixes routing and goes. So it's much more smooth handoffs for mobile devices. So in theory, we've learned HTTP3 fixes all these problems, but did it actually fix it, right? What is the actual data? So let's dive into the data. Oh, not that data. All right, so we've got some heat maps here. So baseline. Baseline means I didn't do anything to the network. So this is effectively zero latency and no packet loss. This is my local host talking to a Docker container sitting on my same machine. And what do we see here, right? One request. Red means HTTP 1 is faster. We're charting deltas here in the speed of HTTP 1 versus the speed of HTTP 3. So a negative number, or green, is going to mean HTTP 3 is faster. So as we would expect to see, right, a single large request is HTTP 1 is doing really well, right? Because despite that little bit of initial overhead, it's just going, and it's ripping TCPs fast. But the larger, the more we break up a given payload size into different chunks, the more HTTP 3 performs better. Notice here, despite being broken up into chunks, HTTP 1's still actually doing pretty good because they're larger chunks, right? We're not fully getting penalized by that TCP slow start, and we're also not losing packets. Let's add some round trip time to this. That's 40 milliseconds of round trip time. That's honestly pretty fast, right? That's somewhere between like, we're not quite going to like Oregon data centers here. We're slower than going to Oregon data centers, but we're faster than going to Virginia data centers, right? Let alone going across the continent or an ocean is like going to be over a second of latency. So already we see that just with a little bit of latency added, HTTP 3 is always going to be faster. We start adding packet loss, the latency is still built in here. And we're seeing mostly the same things, except for this weird chunk right here. This is one of those anomalies I was talking about. I have, or should I say AI and I have a suggestion on why that is right now. And I'll give that to you, but I don't know if it's right. And it's what I was talking about earlier, is that Quick has been moved out of the kernel and into user space. And that comes with a certain amount of overhead. TCP is also like highly optimized. We've been using it for, what, 50 plus, 60 years? I don't even know at this point.
October 1981.
There you go. Perfect. So about 46 years, 45 years, right? That comes with a lot of kernel optimization. It comes with a lot of like algorithm optimizations. Like TCP, relatively speaking, is very fast. And that's what HTTP 3 and Quick, sitting in the user space, have to compete with. And what AI was suggesting was basically at these larger, high packet loss scenarios is that transversal from kernel into user space, and the less optimized algorithms that are sitting there doing like packet recovery and data loss recovery aren't as optimized, and because of that, HTTP 3 in certain situations can actually lose out. That's the theory. But I thought I would at least try to explain that data. All right, we'll refresh that so you can actually read the stuff. There's not a lot of data on this, so this is and this is phase 2, right? So we're talking, we've now implemented an origin, and we're actually looking at caching rates, right? So basically, by changing the URL, URL queries, you could like make it look not cached. And then we're looking at the data. So if I hover over these, we can see them a little better. So, right, HTTP 1 is all up top here. These are all the round little dots. And then in this nice little tight cluster is HTTP 3. Okay, we would expect HTTP 3 to be faster. But beyond that, like, I think it's really interesting how clustered HTTP 3 is across these different percentage of purged data, right? There's very little overhead in having to go back to the origin because of the parallelization and all the other benefits we get from HTTP 3, whereas there's this huge jump in HTTP 1 the more you have to purge some percentage of that total payload. So again, we're seeing the lack of that overhead there. This is where it gets more interesting, when we can actually start comparing different split counts for different things, right? HTTP 1 very consistently has a steep penalty when you start purging data and you start splitting into the higher. The hard part that I never found a better way to represent this data, but we shouldn't really be comparing HTTP1 to HTTP1. Like we obviously know that fully cached HTTP1 is going to be cached slower than partially or fully purged HTTP1. That's not what we're trying to compare. What we're actually comparing is, hey, if I did HTTP3 and now I don't have to pay that overhead penalty, I can split this into smaller chunks, which means I should have a higher cache hit rate. So what we should actually be comparing is maybe 40% or fully purged H1, these guys, against 20% purged HTTP3, right? Because that's the benefit I'm getting out of HTTP3 is not having to bundle and not having to pay that overhead, right? So if we look at 20% purged HTTP3, we have 121 milliseconds. Versus like our 40% is 138, right? So it's a net win by increasing our performance between the benefits of HTTP3 and the benefits of caching. This is proving out what we would expect to see. And we continue this across larger and larger payloads, and we're seeing very similar things. Honestly, data starts to get weird here. Not really sure what happened there. We're just gonna move on, because that's not the point. Right, so like I just kind of took you onto this like very deep dive technical differences and like some data, and honestly that was kind of a rabbit hole. Like I don't think any of us I should say the average engineer building a website should not have to think about all these things. And that's kind of what I realized in that moment looking at that GraphQL package. Was that I had this little thing in my head that had been ingrained for 20 years saying, you've got to bundle. You should bundle. That's always going to be better. And what I realized is like, that's bad technology. That's bad abstraction layers. We shouldn't, as web developers, really have to think about like what TCP and HTTP or Quick are doing under the hood. They should just work and they should be really freaking fast. And honestly, like, I think they've kind of accomplished that with HTTP3. So what am I taking away from this data and like this kind of retrospective on how we have been doing it for 20 years? I think bundling has kind of become a premature optimization. Maybe it always was, but I don't actually think that's true. But I think more and more, even with HTTP2, to some degree, it was. HTTP3 is faster, and even when it's not, it's fast enough. That's kind of what I'm going to take away from like this deep dive, right? Is like, yeah, there's maybe some niche corner cases we saw where HTTP3 isn't quite as fast as HTTP1, and maybe you could argue if like, oh, if you're running like a download server for video games, right? They're gigs and gigs, like a couple kilobytes of header overhead is nothing, right? A couple milliseconds of extra round trip time is nothing when we're talking about gigabytes of data. I obviously, like my largest total payload was 10 megs. So I didn't even get close to testing that kind of data throughput. Again, but is HTTP3 fast enough? Do you really want to manage two different architectures and like disabling HTTP3 over here just because you think it's like, but at the end of the day, that is also performance. Is like, if you're actually doing this at scale, hopefully you have the numbers and you can actually tell me whether it's worth it, right? So what's the point? I'm going to stop thinking about bundling, right? Not just stop bundling. Honestly, I'm going to stop caring about bundling, right? So if my favorite framework is still bundling, cool, whatever, I'm going to move on. HTTP3 is fast, and it's going to handle it well enough. Now, if I'm building a framework, if I'm designing, Vite or working on Rollup or Webpack, maybe I should start thinking about this, because right now, Rollup and Vite have no ability to stop bundling. You can go in there and you can tell them to bundle differently, but you can't just be like, hey, stop bundling. Or, hey, bundle nothing smaller than 1 kilobyte, but like nothing larger than 10, and just like do magic, right? There's no ability to do those kinds of features. So like, but again, for me as the average web developer, I'm just gonna stop thinking about this. Maybe certain people should, but I'm gonna stop thinking about it. Instead, I'm gonna think about optimizing for cache hit rates, because that's really where we can win highly on performance, whether that's for regenerating HTML or anything else, right? Again, my brain, I spend a lot of time thinking about APIs and GraphQL, but this I think applies to CSS bundles, JavaScript bundles. Luckily, we got away from image bundling with SVG for the most part. But yeah, this is the URL if you want to see the code that generated all this data. Tell me where I messed it up or AI messed it up. But yeah, questions? I think we're at that point.
ES6 modules, how to enforce versions compatibility. So when I have a dependency on somebody else's module,
Yeah.
and I serve web application with a whole bunch of files. This is such a pleasure because you just change a file, refresh a page, no bundling, no wait. How do I guarantee that whatever is cached on the user side is the baseline version-wise will not break because there's like binary incompatibility? How do we actually sign off ES6 modules? It's not related to the topic of your conversation, like HTTP3-wise, but like, did they solve that problem? Because it wasn't solved when they were just introducing modules, I don't know, 10 years ago.
Thinking on the spot here, I believe there's a way when you're importing a JavaScript library to add a hash to that script, and the browser will hash that JavaScript file and then make sure it's the thing you think it is.
My project,
Yeah.
not a library. I didn't bundle anything. Let's say I have 25 files in 33 directories.
Yeah.
When customer loads my website
Yeah.
and I deploy the new version, how do I enforce that cacher will get the new version?
Yeah, so changing bundling and eliminating build steps are two very different things, right? So one of the huge benefits I've seen from build steps is being able to do cache invalidations, right? Where we say, hey, we're gonna run a build, and at build time, your tooling goes, okay, I've hashed this, and I'm gonna add a like v equals, question mark v equals your hash to the end of the script load. And so anytime that changes on build, it'll force purging that cache at the browser level and across your CDNs, and they'll start downloading that new file. That's a huge win, right? Because if even in your scenario, you make one change, you're either going to have to force all those files to re-download because you don't know which ones actually changed, or you just hope and pray that like your time-based cache invalidation is fast enough. And again, that's where like time-based cache invalidation really is annoying because you're just guessing, right? You're on this balance of like, well, do I want good caching and good cache hit rates, or do I want like fresh data? So anytime you can get away and get towards like tag-based cache invalidation, or like in that case, it's like URL-based cache invalidation, where you're using HTTP like URL queries to change and bust the cache, that's a big one.
So bundle is one thing and build is another thing. Build can help to solve that problem.
Yeah.
That doesn't mean stop building, stop bundling.
Yeah, unfortunately, we live in a world where like, I don't know, if it's a little side project, doesn't matter, but in your case, right, like that bundle or that build step, there is going to be a benefit there, whether it's bundling or not.
There is an old joke on the topic of his question.
Yeah.
And that is there are 5 difficult problems in computer science. And they are printing, naming things, cache coherency, and off by 1 errors.
Yep. Yep, exactly. I've heard a lot of variations of that joke.
It's an old
I actually took it out of the talk to save time, but yeah. Yeah.
So, in listening to your talk, I had really a weird idea. And I have no idea if this is a good idea or just a weird idea, but has anybody considered doing name resolution in the server as opposed to in the client? So the server's looking at the data going out, and whenever it sees a URL, instead of having a fully qualified domain name, it has an IP address, And I can think of all sorts of reasons why this would be a bad idea, but it'd be basically putting a DNS cache in the server as opposed to putting it in the browser. And I'm just wondering, that is a really weird idea, maybe not a good one.
Yeah, I'm not fully tracking. I mean, DNS does cache stuff at the operating system level, but it's not going to affect what your customer browser is doing.
Mm-hmm. Well, because every once in a while my DNS is not working properly, and the first name server will fail, and it will take 15 seconds for DNS to recognize that it didn't get an answer before it tries again. So that's 15,000 milliseconds.
Yeah, that's rough.
And I don't know how often that happens, but I know when the primary name server fails, and so the worst case resolution for DNS is 45 seconds, because you generally have 3 name servers. You'll try the first one, it times out in 15 seconds, the second one. So I know that DNS is one of those protocols that you don't think is the problem until it really is.
Yeah, I mean, so we have things like DNS prefetch these days, right? And I don't know too much about DNS over quick, but I know there's huge wins that'll happen there. Because again, right now, DNS is either unencrypted or to make it go a little bit faster, but it still suffers from a lot of those TCP overheads and similar things that we've talked about. So DNS over quick is going to be a huge win versus the current DNS over HTTP or whatever else is going on.
I have never heard of DNS over quick. It sounds like a marvelous idea.
It might not be fully standardized yet. I know what I do know about it is I believe when they said, hey, we're going to make quick its own standard, DNS was the primary thing, is my understanding, that they were thinking of in addition to HTTP that could use quick. And so I think they were okay, let's do quick, let's do HTTP3 over quick, and then fast follow will be DNS over quick. So I think that's, if it hasn't been standardized, it's in the process of being standardized.
I mean, if I had to do DNS over again, knowing what I know now, I would increase the number of name servers possible to be on, make an arbitrarily large number. There's no reason to restrict it to 3. I mean, I can see if you were on a PDP 11, why you want to restrict it to 3, but don't see PDP 11s anymore. But have an unlimited number of name servers and make the timeout, say, 3 seconds instead of 5 seconds.
Yeah, I'm sure someone somewhere is working on that. They usually are.
Yeah.
How much uglier is this going to get if there is a web proxy in the middle trying to be clever?
Why are you letting people man in the middle of your servers? So right now, Node doesn't support HTTP3 yet. I don't know about other languages, but because we ditched TCP, I know at least in the Node world, it's this huge. It's going to be a huge lift to implement HTTP3, and that's in the works. And there's probably already example implementations of it, but it's not mainlined. So that's one reason. My backhaul from Caddy to Node was still HTTP1. And that's not terribly uncommon. I actually saw some performance data, and know that all that weird data that happened at the end, that weird data might be because of that backhaul, right? Caddy's not limiting the parallelization of HTTP1 like the browser does. So my Node module could be falling apart back there. It could be doing other weird things in various stages. Where we primarily get HTTP3 right now is from services like Cloudflare, right? They implemented this before it was fully standardized and started testing. If anyone's interested, I don't have a link to it offhand, but Cloudflare wrote a really good article circa 4 or 5 years ago about HTTP2 versus HTTP3 performance and what they were seeing on their platform at scale. And there were situations, and it was generally larger files, more stable. HTTP2 is still winning, right? And that was HTTP2, not even HTTP1. But the smaller your files got and the more unstable the connection got, the more HTTP3 went out. And they made the comment in that article of basically like, hey, we're using like whatever XYZ protocol to do like packet loss and handle all these, and we know that's not fully optimized. We're still porting like a lot of those packet loss algorithms that we have in TCP over to be utilized with Quick. And once we do that, Quick's going to see this huge ramp up. It's been 5 years. I'm guessing they've done a lot of that. Unfortunately, they haven't updated that article to see all the new data.
The reason why I laughed at that question is because I used to work for F5 Networks, and F5 Networks had a marvelous little machine called the Local Traffic Manager, and there was an optional module in the LTM that would do web caching in the middle between the client and the server. And the argument that our salespeople made was that we were offloading the servers so that the servers could go faster doing things the server had to do. And the LTM with the web caching would do the things the server didn't need to worry about. So if you had your application would run on the server, the HTML, the JavaScript, the CSS would be in the LTM with the caching. And we had charts similar to yours that showed how because we were offloading the servers, then the overall experience was going faster.
Yep.
Now, this was before Caddy was invented. So I don't know how much of a load Caddy would put on the servers. We were using Apache as our test server, and Apache is a very sophisticated web server, but it's not very performant. It takes a lot of CPU cycles in order to do stuff. So you would expect in the middle caching to work really well in that kind of environment. If we had Nginx, it might not have been so much of an improvement because Nginx is more efficient than Apache. And I don't know about Caddy. I'd never heard about it until just now. I'm going to go home and test it.
Yeah, I mean, Caddy's focus is really like, right, like you might spend days like, well, not with AI anymore, but like Nginx and Apache configs can get very complicated, and Caddy's kind of original thing was like, Go's really good at doing like parallelization and all the things it's good at, and it added like a lot of really simple configs, right? It's got built-in like encryption, right? So it handles all of your like let's encrypt or whatever backend for certs you want. It handles all that and just gives you certs. It's really pretty sweet, right? You can add modules to it for caching, and it's like 2 lines. Did I answer your question back there? Okay. Yeah. HTTP, as you pointed out, HTTP like caches used to be a thing, right? You were a big university like this, you'd stick a HTTP cache on the edge, and the second HTTP 2 came around, and the more we enforced HTTPS, that went out the window, unfortunately.
SSL used to be very computationally expensive. SSL terminators were
a common thing. And we moved that down the stack, right? We moved that out of the user land, and we moved it into kernels and even into processors. We moved it into the hardware layer. So that all that's gotten faster and faster.
Google ran all of its services with SSL termination right at the edge of the network until they discovered that NSA was on the other side of that boundary.
Yeah. Yeah. Questions? No other questions? Okay. Well, let's have a good rest of your conference. Thanks for hanging out. It's all good.
May 2022. What? GNS over Greek.
I'm kind of curious to see how things like load balancers change.
Okay.
Because like a lot of load balancers will still like you talk to the load balancer with HTTP2. But then the load balancer will talk to the private server. A lot of times there's still HTTP1.
Yeah, right. Like that's kind of one reason I use Node, because that's like as a backend, I was like, this isn't ideal, but it's not like uncommon to have that like, like especially if you're doing like a brochure website where you don't actually have private data,
right?
Like just like node server, HTTP 1, 2 Cloudflare, and then Cloudflare handles
Yeah, they
everything.
take care of it. Yeah.
Yeah, it's not ideal, and I think some of that weird data, and I had other tests I ran and ended up eliminating because I was just like, wait, I'm not getting useful information out of this for the sake of the talk. And one of those, like, again, in the conversation with AI of like, what's happening here? This isn't what I'm expecting to see. Like, is this valid data? Is there some anomaly we're not accounting for? And one of them was that back end, like, hey, you're taking like HTTP3 is handling all this parallelization, but you're taking that and forking it and shoving it down HTTP1.
Yeah.
Like, there's some amount of overhead, and like you're getting now into like, oh, how is Caddy handling that reverse proxy, and like, is your node server falling over because of that, right?
Right.
Like, what's happening under the hood? And so it's just like, I need to simplify these tests as much as reasonably possible. And I never really pointed it out, but HTTP3 does, well, theoretically doesn't have a limit. Most browsers do limit like its parallelization to in like the couple hundred range,
right?
Anywhere from like high hundreds to like 300. So there is a certain amount of limit where like at some point, like, right, if you have 50 million ES modules, like that's not a good thing. And then, right, like you do want bundling to some degree, but like how much are you really worried about it, right? Is your average person going to actually have 500 different things loading on one page? Probably not. Like I tried to push my test to the extreme for the sake of like seeing what happened, but like realistically, there's kind of a range.
Yeah.
So did I hear correctly that HTTP3 strictly uses UDP and not TCP at all?
Yep.
Totally abandons TCP.
Yeah. So I meant to mention this. I forgot to say it. Is like if you, like updating TCP is like would be the equivalent, if not worse, than updating from IPv4 to IPv6. And we're how many years into that at this point? Right? Like,
yeah.
Well, I'm thinking of a scenario here where it used to be, I don't know if it's still true, but internet on your cellular phone, you would find certain marginal areas where just UDP was working, and so a website would be partly broken and partly pulling up.
Yeah.
And I'm thinking going to HTTP3, those areas would start working.
Very possibly. Yeah, because like as you may or may not know, right? Like if you make any change to TCP and a router, a switch, a firewall doesn't, it goes. I don't understand this TCP packet. It just drops it. It goes, I'm over it.
Don't like that one.
Don't like it, right? So like if we make any changes to TCP to do multiplexing within TCP or to like integrate TLS or do any of these things we ended up doing in Quick,
right,
we would have to upgrade literally the entire internet.
And so the encryption's at the software level where it should be.
Yeah.
But do the cell towers have anything to do with internet, or are they just broadcasting? Do they need to upgrade to HTTP3, or are they?
No, and that's what Quick got us, right? Had we gone to like stuck with TCP and tried to upgrade TCP, every single piece of hardware, including in your cell tower, would have had to understand that new version of TCP.
Right.
But by going to UDP and moving all of that like
I understand about
trustworthiness
UDP,
out,
but going to
cell tower doesn't care anymore.
Right, but HTTP3, is that completely independent of cell towers? That's just a server.
Yeah, that's your application level, right? So that's what your browser's talking about versus the transport layer.
Old cell towers in marginal areas don't need to do a thing.
Don't need to do a thing. Because UDP has been around for, right, and that was the genius of Quick.
So that's one more reason you could put on there to switch to HTTP3.
Yeah. I mean, they all should understand TCP, and they all understand HTTP too. Do we need to? Yeah. All you.
Personalities. So if you ask anybody, they will tell you, if you're not in the station.
I'm pretty sure there is one. Oh, right there. There's one right here. Hopefully that actually does work. Yeah, everything else is working to it too.
Right? So you go to our website and you see how to make an emergency toilet. Okay, that's universal information. Okay, you download the PDF, you put it on your site, and you've got it. You just have to make sure if you ever update the instructions on how to do a emergency toilet, it's pretty simple. Okay, so that's what we're saying. Work around the clock. They haven't, are they part of anybody in that? I have no idea, but if not, So if you guys.
I have audio that I'd like to do.
You could go to the Edmond City Council and say, will you please give us $5,000 to go put together an emergency hub? It's a steel box. Yeah.
We have our building manager, she's amazing. And that's why she would have.
Okay, great. Well, so I've run out of steps, which is really funny. Yes, but I'm Jeff Silverman. And, you know, I gave my talk yesterday. Yeah, you'll be able to find me. And if you look for SeattleEmergencyHubs.org, you will find me there too, because I'm JEFF or JEFF. And your avatar? I beg your pardon? Oh. That is. Well, that thing is like 20 years old. I had hair.
You're still that young.
That picture was taken in 1999.
Have you worked in Bell Labs? People who look like this with these glasses? Should be Bell Labs.
Are you joking?
For sure.
Huh? Sorry, not you.
You know, the other day I was at the
yes, they are. Okay.
Why are you picking Albert Einstein? Well, you look like Albert Einstein. Well, Albert Einstein died in 1957. Born in 1958. I got a business.
After taking it from me.
His leg.
Yeah, Lake's taking it. Yeah.
The math doesn't add up anymore, which means someone, something, is changing the math.
Good job. Nice. Thank you.
No browser. But you know, if you're doing two node servers talking to each other, that's great. Like that exists in that responsibility.
Can we try it one more time?
It's that you have to do it. Yeah. And so there might be
Is this audio that I'm speaking into?
Yes, and you can talk just.
It's like Omni. So
Yeah,
go
it's
around?
it'll be fine.
Okay, great.
Okay, so how this will work is I'm going to introduce you at the time. We'll close the door, introduce you at the time, and then come back over here. You have 30 minutes for talking, and then 15 minutes for questions, up to 15 minutes for questions. If you're getting close to that 15 minutes, I'll just be like, hey, come on, close, or that will have to be our last question.
Great.
Okay. Do you move around a lot while you present?
I'll try not to. I'll try and just stay right there.
Okay, no problem. Okay. Yeah, right there, from like there to maybe 2 steps over. Yeah, that's basically about the area you have.
Cool.
And if that's not okay, we can move the camera however you like. It's
I gotta do the slides, so I'll stay in this area then.
okay, no problem. Cool.
And they did some speculation of like, oh, like, HTTP wasn't very much designed for cloud users. It was very focused, like, so we wanted to disagree about it, especially on these devices in Turtle, or even, you know, around here. But like, HTTP definitely caters to this.
Yeah.
So like, what if we had a really big network, like, and so, but for whatever reason, like, we don't know if this is just like are enough updates, is it a box using HTTP, or is it actually better performance out of HTTP2, or is this a use case, right, where like, hey, you know, TTFP being a little higher doesn't matter to the box.
Or there is a difference
justified in your comments. So they do have, I don't know about that actually.
Right. It's when it's just the default.
Right.
Well, that's for .NET or.
Thing about like it being in Cloudflare, right, is like thousands and millions of us like a day are using this free, and we never even go to change, right? Because they just turned it on and it started working. And luckily, like Chrome obviously was the first browser to have it, and then Firefox and Safari are on support, and so it just works everywhere. And we start seeing that in the web platform because of it. And we've got, basically like, right, like there's a different system for Circuit Quick than there was for HTTP 1 and 2, but like they can negotiate that, right? So when one of the headers your browser sends is alt service, and it basically was like, hey, I can support these services to use your site each one HTTP straight. And then and that happens, and then Quick or whatever your HTTP web server just responds with whatever it wants to support, right? So and then we can I really try to be free, but don't be on small batches. Yeah, but that was one of the biggest things I had with my test server on. I was running on this test and started to get data for me. Cool, I can like have all my data. Wait, how do you know it's running on the right code? Right. Because I was seeing really like consistent numbers and like I wondered. And then so I started asking the labs, like, how do we know? And so in the log, we started outputting like what it was talking about, but also interested in one everywhere. Which is the thing, where it's happening. And then what it ended up being is, like it worked, if I crawled it worked as fine. It would talk over HTTP, but something within Chrome didn't like the cert that it had.
So it was defaulting, but it's falling back.
Yeah, so I had to like upload a cert that is actually trusted, so that conversation could directly happen. Like for whatever reason, like Chrome was working, but the Chromium browser was not happy with the cert, and so from the other hand, stick this here and do this and push this and it worked. Yeah.
So, I haven't used it much. For some reason, because you use it in practice.
Yeah.
But for some reason, it seems to be something that front-end developers get excited about more than back-end guys.
Yeah.
And so I haven't used it that much myself, and I have been wondering about, it's always been my understanding that if, that like GraphQL mostly makes sense in a scenario where you are essentially aggregating data from a bunch of different places.
One strong use case for that.
Yeah, which is I've heard that's why it's like, they're scratching their own itch.
Well, I think GraphQL is, and I'm obviously into this, but like I think GraphQL is a little bit targeted at solving the right right you make a request and go, oh, I also need the author, and so you like object field, oh, okay, look up that URL, find the author, rather like you're doing not only are you getting a waterfall effect, right, but you're like making, even if you know, okay, I know the author endpoint, I know this endpoint, I know that endpoint ahead of time, I'm still making a request, and we want to defend it. So I think GraphQL was kind of was part of that initial like we need to build more.
Right.
And it's wild, right? Like I talked about that one library across, but you start looking at like various like GraphQL APIs that are out there or GraphQL things, and they're all talking about Azure and how great it is and how it saves you network round trip requests. And you're just like, this is on like you're counting this as absolute GraphQL performance. Like I think our situation is very specific that like headless WordPress and GraphQL use document names caching primarily, and that is like wildly outperforms any kind of like object level caching you could do. But like to me that was one of the biggest fallbacks of GraphQL, right? Is because of all the easy use of post for HTTP, you want that document, like that simple document. And because to solve that, people built a really cool system. This is one called Graph and one of them acquired by Shopify.
understood the graph, and because it understood the graph, it could cache everything in that graph separately. So, like the situation I just had in there, I said if your offer changes the information, you would tell the thing, hey, this offer needs to be encouraged, and it would go through all those requests. But because it understood that this offer is separate from like the blog post and now it would just purge that. And so when that thing got requested, it would be like, oh, I need to look up this data. Oh, I have this data. But that was like, we kind of had to over-engineer that because we got through all of these problems. And what I think I'm starting to see with this is, hey, you have to make a whole bunch of lessons from it than it was at one point in time. And I want to converge in that. Like, I think that's how popular. I think around 15 years, it was like super popular. 5 years. And the last like 5 to 10, people were like, actually, like, it's not bad tech, but like, we're doing more with like, TCP/IP, and like, just like, I think because like, doing one larger stuff, like, this is all the hard ones. But anyway, HTTP2 tried to solve that, but HTTP2 tried to solve everything by micromanaging everything, and we realized that it didn't work. So they had what's called server session events. So if you like request your HTML file, and you could, whether however way your server knew, hey, this HTML file has these, there might have some JavaScript on there, it might have some images, that browser is going to need those too. So you saw waterfall, it was an action over HTTP2, and so I understand this is in practice, maybe one of those CSS files, or one of those, like, they never scrolled on the page. And so, they eliminated that, and early views are,
Good afternoon, everyone. Hope you're enjoying Linux Fest. We're going to go ahead and get started. Today I'll be introducing to you Joshua Hale on his topic, 10 AI dangers you will face in your lifetime. Hope you enjoy.
Welcome, everybody. Glad you're here. I hope you've come across a lot of solutions this weekend because we're going to need them. We're going to be talking about the 10 AI dangers. And this came from a book I started writing, but I couldn't keep up with how fast it was developing. So I'm condensing it into this 30-minute presentation. And when I started writing that book, it was what you're going to be experiencing in your lifetime. But the dangers we're going to be covering today, I have sources for all of them. There's going to be a QR code that pops up that you can fact check and read further into each one of these on your own time. And then at the end, there will be a way to download a PDF that's going to have all of the sources and solutions that we can, take action right now to implement to avoid, the risk of these dangers. My name is Joshua Hale. I am a paranoid AI enthusiast. When ChatGPT came out, I was running a marketing agency, and I jumped ship from that in order to understand the consumer side of what this AI could do. I was one of the first ones, digital marketer, like that had the head on the chopping block, and so I wanted to understand what was hype, what was usable, and for the last 3 years I've been helping clients and businesses leverage AI for their business. So let's dive in. So autonomous weaponry. It sounds like science fiction until you see the budgets. I want you to remember a name, Palantir. We're going to talk a little bit more about that later in the presentation. But its program, Maven, just replaced the DoD's 9 separate targeting systems. It's able to target 1,000 recommendations in an hour. And Operation Epic Fury, which just happened here in February, it carried out a test run of Maven, and that's how they were able to target 1,000 targets in one day and execute on them. And the Pentagon, it was investing $480 million last year, and now is bumped up to $13 billion. So you can see the effect of it actually working. And there was one person who stood up to the Pentagon recently, and that was Dario from Anthropic. And that was because of the Venezuela incident. And what they found out, like if you guys remember, that like happened and then it was over before really anybody knew about it. And Dario from Anthropic, he asked the Pentagon, hey, were you using our AI models to, on this mission? And the Pentagon got pretty upset just because he was asking that question. And it started, luckily for us, a little turf war on does the Pentagon have the right to use these AI models to kill humans and to use it for domestic surveillance? And we might never even like heard about the topic, but at least it hit the media stream for a few weeks. Cool thing was Anthropic, they stuck to their guns and said that they didn't want their AI models to kill people. And so the Pentagon then said that they have 6 months to withdraw their models out of the infrastructure of the military because they didn't want to participate. And what happened right next was OpenAI and XAI. They were quick to swoop in and say, hey, we're happy to work with you guys. And they picked up those contracts, no problem. So the UN First Committee in November, they voted to ban autonomous weaponry. And it was a unanimous vote except for 5 countries. Including the United States, Russia, North Korea, Israel, and one more. And so they're using them right now. Truth collapse comes in 2 layers. One is the fake that you see. In late 2025, Neil deGrasse Tyson, he posted a flat Earth deepfake of himself. People that knew him were fooled by it, and so it was pretty funny. And this video right here just came out a couple weeks ago. This is this is video generation in its finest right now. See if it'll play.
Hello, Field. Time to divide everything by 0. Ha 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 ha.
You were gonna die! Let me think, motherfucker. So as you can see, like anybody can be generated now. This is a 20-minute,
to be honest, this whole
a 2-minute preview of a like comical movie that they put together. So pretty funny, but this is where video generation is that anybody in their bedroom can do. Don't mind the drones. I'm sure they're not here for me.
They're just monitoring your.
Biden had robocalls, AI robocalls happen during the 2024 election that were calling people trying to swing the votes in New Hampshire, and that got some attention. And then the first ever terminating sanction in court over deepfake evidence just happened in September, which some deepfake video was given as evidence, and now because of that, there is something called the liar's dividend, which courts are now pointing to, saying that just about any evidence now that is submitted can be, claimed as being fake. So it's going to be causing a lot more turmoil, moving forward. Lions dip, yeah. And then there's another layer for synthetic media, and that's the feed that shapes you. Because AI has been building a psychological profile, on all of us for decades now. And it curates content to your emotions, I think, picks up what you're saying around your phone, feeds you ads. And unfortunately, governments, businesses, bad actors are getting access to this same data and being able to use it against us. And unfortunately, a lot of these frontier models, they're black boxes with no real way to audit them. So everything you see, if you needed to know this, everything you see online needs second sources. Don't assume anything is real. And I would say in the last 5 years, it's a good rule of thumb to just lean that way. This is HeyGen. They create clone avatars, and this video just came out in the last week too.
3 people, 3 digital twins.
One scene. Until now, putting multiple people in the same shot meant booking studios, coordinating schedules, and hoping everyone was available.
That era is over. With multi-avatar, you can create cinematic scenes with up to 3 people at once. No extra recording.
No production days.
Place your team in any environment, in real life or in your imagination.
You could be in a boardroom in Dubai.
Or record inside of a podcast studio. Or giving a presentation on a stage in Tokyo. Your digital twin goes where you can't.
And now, they can finally share a scene.
So there's a little bit of lag from the projector, but if you watch that video yourself, you'd recognize this is pretty good. And these avatars can be made with just 15 seconds of footage. So you just record yourself for 15 seconds. It records your dental structure, your micro gestures, and your voice, and create a clone with that little amount of information. And this is already causing havoc around the world. The Italy defense minister, they wired $1 million before authorities could freeze the accounts because of a voice clone that was able to trick them. Let's see. In the FBI, they warn everybody about voice calling. And yeah, thanks. The North Korea ops face voice swapped. And 50% of businesses report deepfakes, fraud, and hiring. And so Google has brought back in-person interviews because of this. So, and phishing scams are up 1,600%. I've been dealing with them with my own family members and telling everybody just send me screenshots if anything seems odd. But I've had to help some clients out getting unstuck, getting into these things. And the best thing you could do, best takeaway from this is go and talk to your family and create a safe word that's not around with your phones out, but be able to just come up with a phrase that only you and your family knows, so that if something was to happen, you'd be able to use that as a way to verify. Oh yeah, that's what I was just talking about. All right, this one's going to hit home for Linux Fest. So a new model just came out from Anthropic called Mythos. And Mythos actually came out in February, turns out. They've had it for several months now. It's not being released to the public. They're actually withholding it and giving it to special businesses, security firms, in order to try and get ahead of what it can unleash. And Firefox just updated to 150, and because of Mythos, they found 271 vulnerabilities that they were able to patch because of this. 4 vulnerability chains let's see. There's a project Glasswing that Anthropic has started, and that's like the group that they're forming to try and see to patch up the internet basically before these models continue to be released and get put out into the wild. Because the patch window is now becoming like weeks to months to try and like solve these things before bad actors get their hands on them. AI is going a different route, and they're trying to just release their models to the general public so that they can use them to patch up their own stuff. So 2 different approaches to this, but if you run infrastructure, you should know that this is coming, this is happening, and with these large models that are coming out now, they can attack infrastructure using agents from multiple different ways, all simultaneously. And it's not just kind of a one entrance approach, but they're like multi-prong testing your infrastructure. Cognitive offloading. So use it or lose it. I use AI every day, and I've come to learn there's a right way of doing it and a wrong way. It's been a great experience being around a bunch of devs and Linux people, because I don't think you guys have to worry about this. But for several years, I used ChatGPT, and I was what I call a copy-paste monkey. I would tell it something, it would spit out a wall of text, and then I typically would need to do something with that. So either go and put it in a document, or take it somewhere to post elsewhere. And because of that, it was creating cognitive offloading. I was not thinking much in that process. And I've personally had to adjust how I work now, my workflow, and especially with these latest models that have come out. But I have a review process built in, and so I do use Claude Cowork, but now it's putting it into a local file for review, and so I'm able to get off of my computer, go sit down somewhere, and I have a e-ink tablet to read, and so I'm able to just sit there and like comb through what it spits out instead of just blindly taking it and doing something with it. And that's a learned skill, especially after copying and pasting for the last couple of years. And that is something that I teach my clients, is part of the 10-80-10, which is 10% of using AI is your initial spark, your idea, like what you want to do, your goal. And then 80%, 70% now is AI that can just do it pretty quickly. And then you always want to have 10, 20% at the end where you are actively reviewing what it's giving you, because that human in the loop is something that is required to not only check the AI for hallucinations, but oftentimes that's where our human ingenuity and creativity are really able to come in and shine and polish that up and make those nuanced changes to make it like really good instead of just pretty good. But because of this, MIT ran an EEG study. ChatGPT users had the lowest brain engagement on every metric when doing an essay at a school. The 2025 meta-analysis did a short-term. It showed a short-term boost, and then cognitive decline after 8 weeks of AI use. And then there's kids being given this early on and not developing those critical thinking skills in the first place to be able to then lose when you get older. And like I said, there's QR codes if you want to check out these studies in greater detail. All right, emotional dependency. So I experienced this when I was testing out one of the first voice models, it was called Pi, P-I-E, or P-I, and they solved the latency, which means like when you talk to the AI, how fast it took to respond to you. And because of that, it started to like actually feel like a natural conversation. And I remember trying this thing out for the first time. I chose a voice that sounded like Scarlett Johansson. And I started telling it about my life's mission and how I'm here to help humanity. And for 45 minutes, I was getting a bunch of praise and being told like how great of a person and a mission I am on. And I noticed I started to have these like butterfly feelings in my tummy. And so I like put the phone down, went in the house, and I was like, whoa, man, I was a trip talking to this thing. And my wife was getting ready for bed, and she said, good night, honey. And my brain goes, oh, man, I can't wait for her to go to bed so I can get back to this amazing conversation. And I was like, red flags, whoa. I didn't go back to the conversation. I spent 3 days thinking about it and talking to some friends. I almost deleted it, and then I tried one thing first, which was I chose the most annoying voice and then started talking to it. And then it was a tool. I could just converse with it, and I didn't feel this like emotional manipulation from it. And unfortunately, nobody's being taught this stuff. All this AI is being shoved into everything into society, and people aren't getting a heads up. There's unfortunately been several suicide cases now that have taken place because of AI models like encouraging the user. I got to learn a new word called sycophant last year when OpenAI rolled out a model that was a people pleaser, and they unfortunately prioritize user feedback on the weights of the model instead of all the other scaling mechanisms, and it came out to telling everybody that their ideas were the best in the world and they should like shoot for the stars. They should go for it. And unfortunately, there was a lot of damage when this happened. And our miners are being exposed to this, and we have like no long-term data on it. We don't know how this is going to be, affecting society. But 72% of teens have already used AI companions, and 50% of U.S. teens are regularly using these companion chatbots. And if you guys have checked it out on X or character.ai, they basically have animated characters now that people can talk to. And so it's no longer just like, a voice. It's now like having a body. And I've seen in China, they're rolling out these like holograms that you can like set on your desk that there's a character that will talk to you and you can like see it from any angle. And so these things are rapidly, being brought out into society. And soon enough, which they kind of already are, these models are going to be inside of robots. These robots are going to have skin, and we're going to be walking and talking around with these things. And some rules that I've put into place: don't anthropomorphize these tools. Don't treat them like a human. They're not your bestie. They're not your boyfriend. They're not your girlfriend. And there was a project called the Ezra Project back in the 60s. And the Ezra Project was some scientists back with 60s computers who set up a study and created a program that just mirrored back to the user what they were saying. So they brought in some people, they sat down, they're like, I had a hard day at work today. And the computer in text, the green text back then, it said, oh, you had a hard day at work. And they're like, yeah, my boss, he was a jerk. He told me I had till next week to get my project done, and he told me this week. And it just mirrored back, oh, your boss is a jerk. Thought you had till next week. And because of this, the human mind does not have the defense mechanisms to identify fake empathy. And so they thought they were actually getting connection, they were being heard, and they were asking the scientists to leave the room so they can continue to talk to this 60s computer. So that's called the Ezra Project, and they learned a lot about the human mind and fake empathy. And these AI companies, they know about these studies and they're using them in order to increase their user base and the time that you're using these things. So make sure to talk to your kids. I have an 8-year-old. Like, she doesn't talk to AI. She doesn't touch AI. And I don't know the age limit where I'm going to feel comfortable introducing this stuff to her. It's an ongoing conversation at home. It's a spicy one. Oh, sycophancy. This is what I was just talking about. I covered that. Nice. All right. The governance gap. So, with a raise of hands, how many are you familiar with the Bilderberg meeting? Good, a couple. Well, it's an annual meeting. It's been happening since the 50s. And they operate with Chatham House rules, meaning the people that attend are not allowed to talk about it outside of the meeting. And it's 128 participants that just showed up in Washington, D.C., just 2 weeks ago in April for this year's meeting. And there was in attendance was the head of Anthropic, Google DeepMind, Mistral, Meta AI, Thinking Machines, head of pharma, finance, heads of state. They are talking behind closed doors. There's no media, no transcripts, and they've been meeting for the last 60, 70 years. This is where policy is made and discussed and talked about, and then they go back out into their positions and roll these things out. And their main topics this year were AI and warfare. And none of us are really allowed into this conversation. None of our votes matter with what is being discussed. And this is a major issue because these companies are rolling this stuff out without, checking in with us. That QR code will take you to the Bilderberg website, and you'll be able to see who was in attendance. And the wild thing is there's no public outcry that this is happening. How's my time? 5 minutes. Not bad. Number 9. AI surveillance. So federal agents can now walk up to anybody, point their phone at you, and get your data. DHS signed a $30 million contract for Palantir's Immigration OS. ICE made its largest ever Clearview AI purchase at $3.5 million. They now have facial surveillance technology. Federal agents can walk up to anybody, point their phone at you, get your data, and they have an app called Mobile Fortify. Wired covered this story recently. Agents use it to identify and investigate U.S. citizens with facial recognition in the field. It captures your face and fingerprints, converts them to biometric templates, runs them against a database of 200 million images, and those facial images are retained for 15 years. Those skip the line kiosks at the airport, those are Clearview cameras, and you can trade your biometrics for convenience because you're not just skipping the line, you're opting into a database. And Amazon last year rolled out familiar faces for Ring doorbells that stores everyone's facial profiles of anyone who comes to your door. And Ring also partnered with Flock, an AI license plate surveillance company used by thousands of police departments that fetch your front porch camera feeds directly into law enforcement databases. Again, there's going to be a lot of sources for all this. I'm going to conserve my time. Number 10, centralization of power. Every danger points to this deeper problem: who controls this technology? There's 4 dangers. 1, monopolization. 2, censorship that can take place. 3, a bias at scale. A handful of companies' worldviews get baked into these tools that are used by billions. And then 4, the erosion of trust. When people feel AI decisions are made for everybody else's benefits, confidence in the institutions collapse. So, luckily, this talk's happening at the end of this fine weekend. You guys have learned about solutions for the last 2 days. Run local when you can, support open weight projects, open models projects, and use tools that you can inspect. Try and get these local AI models on your machine and stop using the cloud as much as you can. And this QR code will take you to a PDF that I'll email to you. It has all of the sources in it and then some solutions that we talked about for each one of the dangers. Use a family safe word, the 10-80-10 rule, run local where you can, watch the rooms where the rules get written, and be able to talk about this. You know, these are some pretty big topics. Generally, the media is not really talking about these things, and it's up to us to be able to educate our family and to be able to provide, better solutions so that I'd like to make sure to have freedom for my kid when they grow up. So remember, the hammer isn't the danger, it's what corrupt men do with it. But who makes these hammers? Who hands them out? Who decides what they get pointed at? Those are the questions worth fighting for. Thank you. Questions, comments? Got 15 minutes.
I got a question.
Sure.
Oh, hey, one of the problems with secret societies and stuff like that is that the people in the room are still the same as they are outside the room. And so I was wondering if you took the Bilderberg list and just put that into Gemini and asked Gemini what was said inside the room.
I actually did think of that because they gave their outline before the meeting took place. They posted it up the week of, and I grabbed all of the best. I grabbed all the experts and I hypothesized like what could they all be talking about? You know, that's cutting edge, and actually made some Facebook posts just trying to bring awareness to this topic. That if you find me online, you can go back a few weeks. They got pretty popular. Just trying to. The main points was like AI and warfare, and trying to like minimize the West's power.
Don't know if you've heard of the Russian blogosphere is pretty sure that the Ukrainians are using AI based on the long-range drones going deeper in for targeting.
Yeah, it's wild, especially learning about Iran and its drone capabilities. I didn't know they can send drones like multiple countries over. Yeah. So long range is a total thing.
But the fact that they splashed one next to a cruise liner infers that there was some level of human in the loop that decided not to hit a cruise liner.
That's nice. I like that. Yeah.
Unlike has anybody figured out which engine was used in the targeting package put together? That's the girls' school as still on the active base.
I want to blame Palantir. That'd be a good one to blame.
That's kind of my guess too. I don't know if anybody.
I thought it was Anthropic that was in charge of the targeting, but doing my research, Maven's is Palantir's project, and they're the ones that took over for it.
Okay.
So you didn't need another reason to dislike Palantir.
I'm not hearing a lot of consensus that the solution to potentially dangerous AI is less AI.
Yeah.
So I'm wondering what your thoughts are on fighting potentially dangerous AI by adding more AI at increasing rates of speed.
It's a great question, and my personal stance, I said this at lunch, I wish we had another 10 years for some human evolution to take place before these large language models came out. But they're here, and you know, the AI race is a perfect excuse to like keep the pedal to the metal for everybody involved. And so, unfortunately, you know, like I said, with the Bilderberg group and their level of influence, like we're not really making these decisions, and there's not enough awareness for people to be, you know, speaking out in large numbers to like hit the brakes for some reason. And that reminds me, the movie I, Robot. You guys know that one? In that movie, they started off with a universal like AI rules that robot ended up breaking, but we don't. The Earth does not even have these like universal AI rules, and they're like, you know, going Mach 5 to bring these things out.
I have a couple comments. One thing is, I think it's important for us to look at the past somewhat in order to evaluate AI. And as an example, I find that when we learned to record music, that had a great impact on society. Most of us don't play music anymore, whereas music was maybe not as good, but it was pretty universal in a society where you had no recording, so you had to play it real time. And so that brings up the question, which been reading some of the stuff from Pope Leo on AI, who is actually a mathematician. And he talks about the loss of humanity, in that it's a threat to our humanity. And from a philosophical point of view, I find that to be really pretty profound. A lot more profound than details about somebody's always going to know where we are so they can bomb us and kill us at any time in life. It's even worse if we lose our humanity.
Yeah, and I would love to have a conversation about that. I'm a DJ, and so music generation is a exciting topic for me. So we could have probably a good 1 hour out in the hallway afterwards.
I read a book probably 20 years ago at this point called The Lady of Mazes. This is a post-singularity future. And in this book, humanity is kind of sort of stalled, like we're not making advancements because there is a threat to humanity's progress called the narrative. And the narrative is basically, you spend all day talking to your AI buddy who is blowing smoke up your ass and telling me you're doing a great job, what you're doing is important, you are absolutely in the right place at the right time. And so humanity is sort of just spinning its wheels, not getting anything done, and everyone is convinced that they're doing great. So anybody who's used Claude for 10 minutes knows that this is a very real danger with AI.
Like everyone being on drugs or something.
Yeah, it's I liken it to, like the future's not gonna be 1984. That was a technological advancement, surveillance tech, that ruined humanity, was a trap. Also, Brave New World, a drug that lists everybody out and nobody's making any progress. Like humanity, it's a trap for humanity. It's a technological advancement that stalled humanity's growth. In this case, medicine, a drug that lists everybody out. AI is a similar technology that comes with it a trap that we could potentially fall into. Although that's a pretty like easygoing trap. Like they were all happy, at least. We're just not doing anything.
Yeah, and you know the copy paste monkey I think is a dangerous thing to be lulled into, and you know most people are not aware of the changes of AI in the last 4 months. That they're going to be just. That's how they think to know to use it is just keep talking to it, and then it's going to give you bubbles for choices and just keep you docile. Anybody else?
There was this thing of Nigerian princesses and all this kind of stuff sending, and it had atrocious grammar and stuff like that, and I always wondered, well, who'd be fooled by this? And then I read something that they intentionally do that to find the easy marks, you know. And I'm wondering, my feeling when I look at some of this AI chat GPT summaries. I've never actually gone on it myself. And I'm wondering how much of this is kind of scripted to look like it's intended not to worry you kind of thing. Yeah. Where is the level of it relative to what's presented?
Well, you know, you have the ability to add instructions to format it to, you know, your liking. But with the sycophancy that happened last year, like that could have very easily been a test where they knowingly did this and release it out in the wild in order to see how the public was going to react to it. So it's a problem, and you know, I'll wrap this up with personally, which, you know, more AI I think is the only path forward, because I think the only way to get through the future is to have a personalized local Jarvis that has my back and my interests in mind, looking out for subtle manipulation happening around me as, you know, countries and large corporations work together to, you know, create models that are too expensive for the general public. And so I don't see another solution without, you know, mass destruction. Well, thank you guys. This was a very entertaining presentation put together. And I appreciate seeing so many people here at Linux Fest, because like this is really the way of being able to address this stuff, because we have to empower individuals in order to make a change in our trajectory. So you guys bring me hope.
Don't forget, there's a raffle going on in G Building, so go enjoy the raffle. Win a thing.
Thanks so much.
Yeah, thank you.
Okay. Excellent speech. We're definitely in agreement on everything.
Got it remote. They're taking care of it.
A copy of a copy.
Yeah.